Не се виждаш. Здравейте и добре дошли в поредното издание на OpenFest. I will switch now to English because our lecturer this time is not a Bulgarian speaker. We will hear Peter. Yeah, maybe you are a fast learner.
Oh.
About it, Konstantin, who is a security engineer, sysadmin, and consultant, which is the OpenBSD packet filtering system. And today he will talk about OpenBSD 6.8, which is the 25th anniversary release of OpenBSD. More he'll show us we should care about OpenBSD even if we have never used it or plan to use it, and how it helps every one of us. So, Peter, giving you the presenter rights, and you can share your screen, and happy to hear you.
Good morning, good afternoon, good evening, wherever you are. Thank you very much for having me here. I'll be sharing my screen in just a bit, so you will get my presentation. So there we are. As always, well, welcome to OpenFest. This is OpenBSD 6.8 or how to have fun with the world's most important free software project. My preparations were mainly that you should probably take time to type that URL into your browser so you can follow along the slides. Everything in this presentation that looks like a link is, and links to things that we will probably, links to basically background information that you might want to explore on your own. So here we go. Now, OpenBSD, well, the world's most important free software project, OpenBSD, has been around for 25 years. It was started on 18th of October 1995, so it's a couple of weeks after Happy Birthday OpenBSD. It was 49th release. Now, why would you care about OpenBSD? Well, for the reason for being for OpenBSD is that it's proactively secure. And has managed to have only 2 remote holes in the default install in almost 25 years. OpenBSD started basically as code audits, like basically going through your code and looking for errors and correcting them everywhere. And it's been doing that for 25 years and it's still ongoing. We're still finding bugs. OpenBSD pretty uniquely has all security enhancements as they come along and are deemed safe enabled by default. If you start trying to take them away, things will break badly. And finally, OpenBSD is open source, it's free software, and by virtue of being available in real time, it enables independent verification. So basically, maybe it's a moral hint for other developers to, well, you should think about doing this that way too. Why should you get involved? Well, OpenBSD has quality image, quite high profile, based on the quality of the code and where it's used in the real world. OpenBSD is the origin or upstream of several widely or almost universally used free software components, such as OpenSSH, OpenBGP, the routing daemon, PF, of course, which is the best firewall ever, OpenSMTPD, the relatively new entrant into the mail server market, LibreSSL, which is a heroic attempt at cleaning up TLS code, and various other things. Now, if I drone on too much, you could usefully go to that first link there at the innovations page in the OpenBSD to get a few ideas of what the code, what the OpenBSD project has been on about for almost 25 years. Now, why is it called OpenBSD? Well, one of the things that was remarkable about the OpenBSD project at first was this was the first open source project that actually made its code available online in real time via a anonymous CVS access. Like anything that's committed to the tree is immediately available to the world. So basically, we've been growing up in public for 25 years. It's a little rough, but it tends to work out. Now, who am I? I'm Peter Hanstein. I am an OpenBSD user since a little before the turn of the century. Of the several titles I've had, my current one is security engineer, which means in practice, I do Unix things for a security team deep inside T2Every. I'm afraid I cannot offer more detail than that for contractual reasons. My main claim to fame is I wrote the book of PF, which is based on my experience with using OpenBSD in various real-world situations. And of course, I also learn a lot by doing lectures like this at conferences. If you're interested in what I do other times, well, I do blog as well, and any decade now, I probably will manage to get around to get another book out. Now, what is OpenBSD? OpenBSD says a lot in the default motto, welcome to OpenBSD, the proactively secure Unix-like operating system. We have also been batting around mottos like free, functional, secure, and secure by default, which are, well, as you will see, basically true about OpenBSD. And you may or may not be aware, but you are already using this code in to some extent, because OpenBSD code is in your Mac, in your iPhone, in your BlackBerry, in your Android device, even in your Solaris server. Cisco networking products are full of it, and all Linux distributions, all Unixes, and even in relatively recent times, Microsoft started putting OpenSSH in their base system. And actually, Microsoft, for all their faults, they're actually a financial contributor to the OpenBSD Foundation. I forget at which level, but they actually contribute financially. Now, let's get to the details then. Well, as I already mentioned, OpenBSD is about proactive security. Reading the code like the devil reads the Bible has spawned a few things, various exploit mitigations in quasi-random order. Address space randomization was not actually invented by OpenBSD, but OpenBSD was the first operating system to actually enable by default. So basically, your code is loaded at quasi-random positions in memory. So your return-oriented programming just has a relatively little chance of even working. Another nice little thing we have is that memory can be writable exclusive or executable. So basically, you cannot write to executable memory. On memory allocations, we add a unreadable and unwritable page after the allocated chunk. So basically, your code starts to overrun. Well, that will crash, and that's what always happens. Well, if you run into these mitigation thing, well, what happens is the code will crash, and well, basically, you don't get anywhere. On the nice side of things, we have like restructure your code so you have privilege separation. It turns out that most daemons do not actually need higher privileges at most times. So you separate out the things that actually do need higher privilege, and you run that in a separate process. The rest of the bulk of the work, well, you can run with a specific user that owns the resources that process needs and just doesn't see anything else. SSHD was the first major daemon to go through the privilege separation path, and basically anything that's in the base system now has been treated as well. Now, the flip side of privilege separation is that you have privilege revocation. So basically, your privilege separated daemon will drop the privilege as soon as possible to stay functional. As I touched on earlier, privilege separation usually runs hand in hand with the daemon actually running in a root jail, restricted environment where basically nothing is available, not even a shell. Well, basically not a shell, nothing in your home directory. So it's really hard to escape from there. Another fancy name for randomization was ProPolice. It's basically a compiler trick that fiddles with your stacks. So there is a random gap in the stack inserted. So again, stuff like trying to go for fixed returns just doesn't work. In more recent times, we started fiddling with the syscalls. In OpenBSD 5.9, we introduced the pledge syscall, which allows a programmer to restrict your program behavior to only things that are in your pre-declared profile. So basically, if your program does not actually need file system access, if you somehow try to go for a file system, well, you die. One relatively expensive thing that happened in OpenBSD 6.2 was kernel address randomized link, which means by at boot time, your kernel is relinked in a randomized layout. So again, various exploits that depended on knowing the return address, well, basically that does not work. The downside was that the base system grew by about 300 megabytes because we needed all those kernel object files for relink. So it has a downside, but it was deemed to be worth it. OpenBSD 6.4, only 2 years ago, introduced Unveil, which is this is called specifically to restrict file system access to, again, a pre-declared profile. Practical result is such things as on OpenBSD, your web browser, typically Chrome or Firefox, will only ever be able to see its own download directory. And in all those cases, the motto is, where it is possible to spot damage, fail hard. Basically, your program dies. Now, short history of OpenBSD, as we all know, it came from somewhere. It descended from what it was known as BSD Unix, or Berkeley Software Distribution, which again started as a collection of useful software for Unix. And why Unix? Well, Unix was available in source form for academics. Over time, this evolved into an environment where they were actually starting to improve and replace the code in the operating system itself. It became good enough that the BSD Unix environment was the home of the TCP IP reference implementation in the 1980s. By the time the 1990s came around, the project was started by the U.S. Department of Defense to make a distributed network called the Start ARPANET, developing into the Internet for internet working. Well, this research was done, the internet was there, so funding dried up, and what to do with the code? Well, there were a couple of groups that had some ideas about that, based on a series of, what turned into a series of Dr. Dobbs articles about the 386 BSD project. Well, two separate groups that did not know about each other started hacking on that code. FreeBSD, which was BSD on IBM PC compatible hardware, and NetBSD, who would take just anything that was digital and try to run BSD on it. And of course, the little showstopper turned out the commercial effort called BSDI, which provoked a lawsuit from the owners of the original Unix code by doing full page ads in some Bay Area newspapers with a contact number of 1-800-ITS-UNIX. That was eventually settled in 1994, but it provided the window of opportunity for Linux, courtesy of Linus Torvalds and the gang, to gain prominence. OpenBSD, as I mentioned earlier, was forked from NetBSD in 1995, and well, it started growing out in public by providing anonymous public CVS, so all over the world you could see the code change in real time. Now, in more recent history, since then, in 1995, we have had a release every 6 months, roughly May or November. That has been stretched at times. The most recent one is OpenBSD 6.8, released on October 18th, and our 49th release. As I mentioned earlier, the emphasis on security and usability, and usability turns up in things like you would expect OpenBSD developers to run on their laptops. Specifically, certain ThinkPads are extremely well supported in OpenBSD. As I mentioned earlier, upstream for several things you will be using, such as OpenSSH. I don't know who the other 3% are for the market share there, but there are other SSH daemons out. OpenSSH has 97% market share. OpenNTPD, which was a very welcome entrant a few years ago as a new routing daemon. And the network time daemon, OpenBGP, as I mentioned earlier. Other things, PF, the packet filter, which I've sort of written about, OpenSMTPD, the mail server, OpenIKD for same key exchange for your VPNs. LibreSSL happened a few years back. You probably remember Heartbleed. Heartbleed did not cause LibreSSL to split off, but the project was started only a few weeks before the Heartbleed bug was public. So also OpenBSD remains its own HTTPD, a DHCP, full IPsec toolsuit, and so forth. Again, the innovations page will give you all. The concept of hackathons, there is some was Sun Microsystems or OpenBSD that originated that. Anyway, we were early with that one. So, and of course, every OpenBSD release since OpenBSD 3 has had at least one song. OpenBSD 6.0 had 6 to mark the end of CG releases. That's right, you can't buy OpenBSD CDs anymore. You probably wouldn't want to either. There are other ways to contribute. Now, OpenBSD is all about security, code audit. Like the way you do it is, well, you start reading the code. You assume a hostile environment. You look for unsafe behaviors. Like, well, and since programmers tend to think alike, you fix one bug, find one bug somewhere. You will go through the rest of the tree to fix similar bugs everywhere else in the tree. And this has been going on for 25 years and it's still ongoing. So all this, of course, accumulates, the experience leads to exploit mitigation techniques, and it's very well worth digging into what's been written about these stuff like write X or execute, privilege separation, and so forth. There are two very good summaries referenced in this paper, written about, spaced about 10 years, but what I was thinking at one point and what happened during the following 10 years is worth noting that at one point in history, well, OpenBSD was the first free operating system with really strong crypto in the base system, which made it technically illegal to re-export OpenBSD code from the United States. The law changed, and well, basically because time went on, but at one point that was sort of a problem. People would actually drive to Canada to hack an OpenBSD code and come back in the United States afterwards. The goals, some of them mainly achieved, is to have secure and correct code. Also, you want a usable system, so you want same defaults, and you want readable documentation. Upshots of all this is that it is strictly forbidden in OpenBSD to commit new features without a matching man page. And you will see other documentation now on the website and elsewhere. It doesn't mean that it's useless to write a book about OpenBSD, but it actually comes quite well documented out of the box. Again, please do look up the other pages here. What is also part of OpenBSD's profile is done by a relatively small team. At any one time in history, we have had roughly 100 active developers. There are people coming to the project and leaving for life reasons. Historically, about at the 20th anniversary, Theo posted a summary that said historically roughly 356 hackers have been involved over those 20 years. We have had some recruitment afterwards, so that number has grown a little, but still at any one time, roughly 100 people involved. So why would you want to use BSD? Well, Unix. It's real Unix, and we will never have System Z. What would like to be? Well, what I found when I approached OpenBSD for the first time after being in a few other Unixes was that it was clean, uncluttered. Everything made sense, and well, a full install with every full install is a base install with compilers and X and everything. It used to be about 600 megabytes. It's now, with the kernel object files, 962 megabyte, but it's still small compared to basically anything else. Your basic install will come with no services listening by default. If you want to run SSHD, you have to, well, you will be asked by the installer if you want to. As I said already, it has your basic development tools in there, and it runs on actually 13 platforms. OpenBSD 6.8 introduces 64-bit power again. We no longer have the VAX because basically all the VAXs do not travel well. And well, anything that is not in the base system, but it's available as free software. Well, there's a good chance it is in our package system, based on the same philosophy as the FreeBSD ports, but we do boundary packages for all architectures. The number of actually built for each release varies across architectures. AMD 64 has 11,234 packages pre-built. The numbers for other architectures vary. And again, there's a very clear separation of base system things and packages, so which again it contributes to the unclutteredness of the system. So why would you use OpenBSD? Well, IPsec was, well, it's not a base system. It's been since OpenBSD 2.1 in 1997, which, well, it's nice, but the thing is, well, it was always hard to configure until OpenBSD 3.8 when we got IPsec CTL. This is actually a simple but complete configuration that's listed there, setting up the flows, and you have the IPsec VPN right up there. Compare that with others such as Microsoft, and there's a actually quite fun presentation from HBSDCon 2007, which lists all the 36 dialogues you have to go through, and still not be quite done with Microsoft. So it turns out, it boils down to IPsec should not be this hard. The default should make sense. What you will see where in OpenBSD the default should make sense. That the modern tools, IK control, if you're setting up with OpenBSD IPsec, you will be able to generate config for Windows and Mac OS clients right from the OpenBSD tool. Now, why use OpenBSD? Yeah, the OpenBSD packet filter was debuted in OpenBSD 3.0. Just after the turn of the century. It was written because we needed it. Turned out the IP filter, which migrated from Solaris or Sonos, and the original was actually not freely licensed, so we needed to replace that fast. And fortunately, a young man called Daniel Hartmeyer had a prototype which was further developed quite quickly. It has been rewritten afterwards, but the user visible parts have stayed remarkably stable. Anyway, it's a high-performance packet filter with a human-readable config, and so basically a very admin-friendly interface to doing your network administration. Ties in with a number of other tools that we'll get back to, and for all those reasons, it was ported to several other systems such as FreeBSD. While that turned up in the other Apple products, NetBSD through BlackBerry, and finally Oracle through into Solaris. So OpenBSD, the packet filter, is enabled by default since OpenBSD 4.6, which is quite a while back, and it even has the default rule set in your RC that enables you to do things like, okay, if your handwritten rule set is not valid, you still have a valid one loaded in advance, so your NFS mounts will work, your SSH will work, so you can log in and fix things. And of course, this is, if you want to know more about PF, there are links here for the book of PF. I'll be very happy if you can go there and buy that one. Or if you just go to the PF tutorials, also linked here, you will hopefully find some useful information. Part of the, well, one of the things that ties into PF is the traffic shaping engine. Again, here we have the new traffic shaping that was introduced in OpenBSD 5.5, which is a relatively human-readable thing here, where you set up queues on a specific interface and a specific bandwidth, and you do what turns out to be a fairly flexible allocation of your shaping here, and all of this should then be tied into your rule set again with match. Just hung on to your retro path rules with a set Q argument. Recent OpenBSD even has the FQ codel fair share queuing, which uses a different algorithm than the HFSC one here. I would strongly recommend looking into the article referenced here if you're interested in the buffer bloat problem, which we could get back to in the questions section, I guess. OpenBSD, again, something that ties into the PF toolchain proxies. We have TFTP proxy and FTP proxy and base, and you tie them into your config with again diverting in your rule set. Other proxies such as Squid, Snort, and others will be tied into your config via divert to as well. One of my favorite tools, SpamD, also again hooks into your PF config. It's a little daemon that speaks a little less than TP, and again, a divert to thing. Started out as pure target with a predefined blacklist. Soon grew gray listing. Gray listing grew into gray trapping, which means you, if you have a list of bogus addresses in your domains, anyone tries to deliver to that, they will be blacklisted as well. And I've written extensively about this, so you can go to my blog and just search for the keyword spam, and you will, there is some hilarity out there. Anyway, I've used this to deliver basically spam eating appliances, and it can be a lot of fun. Now, for your more complex setups, you want redundancy if you can afford it. So what happened in OpenBSD 3.5 was that finally we got the patent-free replacement for Cisco's virtual router redundancy protocol, VRP, only this is actually a general redundancy protocol thing, not just for routers. What it does is we set up a virtual address, or actually a virtual network interface that carries one or more virtual IP addresses that will fail over on will fail over when needed. Combined with the if state daemon, you can set up rules for what is essentially a full service cluster solution. And old style clustering or failover. For your redundant firewalls, we have failover. You will also want to sync the state table. We have PF sync for that, which is again a virtual network interface, really relatively easy to set up, and you will want that on a separate physical interface or sort of the VLAN. Again, go for the man page link there. It will all make sense. For your IPsec setups, same thing. SAsyncD will just Bob's your uncle. Now, for your proxy load balancing needs, Relay-D. It does your simple level 3 balancing over address pools with that host detection, and you can take hosts in or out for maintenance and so forth. Or if they just fail, again, it all looks pretty transparent to the rest of the world. Level 7 balancing with filtering and redirect based on things like headers and whichever browser you're coming from and so forth. Of course, we have a TLS termination, and because it was needed at some point, Rick wrote in upstream router balancing. So basically, if one of your known routers fails, well, Lady has some features to actually work around that as well. And well, we would not be here without some virtualization. OpenBSD introduced VMM, and the supporting VMD in OpenBSD 6.1. It's a full-featured hypervisor initially for AMD64 and i386. i386 was later dropped because it turned out to be not that useful, but you can still run AMD64 and i386 guests on AMD64. Originally only for OpenBSD guests, it now supports Linux, and I know there's some work going on for supporting other platforms as well. Then again, something that requires some deep surgery, so you would be running OpenBSD or Linux guests. I am not actually sure how well other things would be supported. Pair off with that is switchd for your software-defined network needs. It's an OpenFlow S-Flow controller, which basically implements that. I forget what the RFC is called. Anyway, to get started with that, the place to start is to look up the OpenBSD virtualization FAQ on the OpenBSD website. Here. It's also worth noting that for several years before we got VMM, we had LDOM support on OpenBSD Spark 64, which is the Spark hardware-assisted virtualization. That's actually quite nice, but unless you have Spark 64 hardware, you're not really going to care about it. So, why OpenBSD? Well, this is more for the SUSE, really: innovation, security, verifiability, and transparency. As we mentioned already, OpenBSD is upstream for code that you use everywhere else. What's specific to OpenBSD is that security features are typically enabled by default ahead of anywhere else in OpenBSD. For your commercial profile, it's worth noting that your users and customers have tended in recent years to demand transparency and a verifiable process. Looking at what OpenBSD does helps you maintain that. OpenBSD has been going under code audit for 25 years, and as I said earlier, only 2 remote holes in a default install and all that time. And we are basically repeating ourselves here with the code audit that's been going on all those years. We run the security enabled by default, and we are really looking to enable independent verification. And if you go along with all this, the OpenBSD quality image might actually rub off on you, and your customers might like it. So why use OpenBSD? Well, what I've been doing a lot is use OpenBSD to replace proprietary products. There are a lot of thingamajiggings out there that will do stuff, but you can't really get to the end of it. And of course, OpenBSD runs well on whatever hardware you have lying around. It doesn't really cost anything to get started. And it's a full-featured platform with the best-of-breed toolbox for at least network-centric things like a firewall router, VPN, spam code, load balancer, traffic shaper, general server roles, and it's a secure development platform. In most server roles, it compares favorably with the other Unixes or Linuxes, and once people have a few days or weeks to actually get used to the system, they will love it. Even commercial support is available. The project maintains a list of support sources here. So you shouldn't be really scared of that either. So OpenBSD, yes, OpenBSD works on your laptop, probably. Just throw it on there. One of the things that should warm your heart is that it's actually one of the main development platforms for X.org. So that's a good chance that if your hardware is actually supported. Whatever desktop software you will be wanting to use as long as it's free software, it's on there. There's even been some work in the recent times that Wi-Fi drivers have come from OpenBSD and to FreeBSD. To the extent that FreeBSD developers do not use Macs as their laptops, that's useful. And as I mentioned earlier, OpenBSD developers tend to run OpenBSD on their laptops. And worth noting, of course, that certain applications do not behave well and may need some tinkering. I've had a short run of OpenBSD tutorials on that. I might even revive that if it turns out to be useful. So why would you not use OpenBSD? I've given this talk a few times, and I was thinking not to include this, but in the real world, there may be projects that have specific requirements, such as commercial software that does not run well or at all on OpenBSD. More frequently than that, I've been subject to people who say, we don't know OpenBSD, we don't want to use it. Well, it's fixable if your staff actually has some Unix background. It shouldn't take long to be up and running, and in my experience, people tend to love it. And again, if you don't know if your hardware is supported, well, just hang on, get a spare unit, try and install it, get it up and running, and you will probably be pleasantly surprised. OpenBSD versus the competition. Well, it's compared to all those commercial things, there may not be all that glitter and bluster, but well, yeah, you start out with a license fee of $0, although donations are encouraged. Your upfront investment will be training. The setup costs will equate with hardware and time work. In the short run, in the short run, your project will probably be, your colleagues will be modding a lot once they get a hang of it. And your long-term perks, well, if you're a suit, the OpenBSD quality image is probably going to rub off on you. So with the emphasis on quality, security, and reliability, and the fact that we've been doing this growing up in public for 25 years. So OpenBSD 6.8 news. Well, OpenBSD, it's actually quite a boring release, except for we have a new platform. The Power and non-virtualized systems debuted here. It certainly is ongoing. Lots of commits happening as we speak. So you should be seeing that expand a lot. So it's early days yet. OpenBSD 6.8 has incremental improvements everywhere, such as even better graphics support and all sorts of driver support. A lot is happening in the network stacks, going for improved performance. We have WireGuard VPN in kernel now from OpenBSD 6.8, which was again, all these links are to undoubtedly org articles about the actual implementation. Login LDAP was added, so basically better and more well integrated LDAP support. FFS2 is now the default for new installs on almost all platforms, and of course FFS2 has support for really large file systems, and again, do look up the articles. LibreSSL was even tweaked better and now has TLS 1.3 enabled. and a number of incremental improvements. So please do look up Beck's report here. Unveiling again, happening all over the base system. Further work in return-oriented programming, gadgets removed from several platforms. The ongoing work in VMM and VMD. The ongoing, never-ending saga of improvements for multiprocessor support, specifically in the network stack, is ongoing. Again, a lot of betterments in the wireless stack, and of course, the Intel CPU bugs that would make security horrible. Some of those were mitigated before Intel actually admitted they were there. Do look up the release page and the changelog for any really gory details. Now, what's going to happen in the long run? Well, of course, we have a number of, again, incremental improvements happening. And the good thing is that even if you don't want to check out the code by CVS all the time, the plus page is generally updated quite aggressively. So do watch that there. So again, the improvements are slithering in, slanting to security, and stuff that will happen in your Linux distribution. You can see the preview in OpenBSD. Now, for your OpenBSD resources, these are the main ones. Of course, the OpenBSD.org web page, and if you're actually using this or wanting to contribute, to look it up. Certainly the donations page. The Undeadly.org is the OpenBSD journal news site. I'm one of the editors there. This is where you would look. I wouldn't look for it to be updated every day, but at least a couple of times a week, something will turn up there. There are several good books out. I would emphasize Michael Lucas's one. You will also see, well, stuff like my blog posts and so forth. And of course, if you want to support me, well, the Book of PF is still in its third edition. We will see what happens with that later. And of course, your bunch of links from this one. This presentation is really a lot of links wrapped in a little propaganda. So please be welcome to that. Now, your feedback form. The URL indicated by the QR code, that leads to the feedback form for this talk. And I think if there's any time left, we'll be happy to do a Q&A. So thanks for having me.
Thank you very much, Peter. Unfortunately, we don't have much time left for questions. So, of course, the viewers can follow your feedback form, or you can also head into the Bulgaria Hall discussion room to have a chat if somebody has some pressing question right afterwards.
Right.
Yes, thank you again. It was very interesting to learn about OpenBSD and how even us Linux people benefit a lot from your work. So thank you for all the fish.
Yes, right. So thanks for having me. I will see if I can find the chat room and stay around a little bit.
Yes,
so, thank you very much.
You can check around in case somebody wants to contact you. And for the viewers, we have a 10 minutes break, and you can join us again for the next lecture at 12 Bulgarian time. And also, I would like to thank all the sponsors of OpenFest for making this online edition possible. See you soon.
Bye.
Hello, and great thanks to our sponsors and print partners. Sorry. You can visit the rooms from our site. After this session, you can also join our discussion rooms to have more questions and answers about this presentation. Let me introduce our new lecturer, Christoph. He's a freelancer again, for embedded software engineer, specialist in network and video application. He's a FreeBSD committer, maintainer, and the PF firewall in FreeBSD and board member of the EuroBSD Con Foundation. So you can present. The microphone is yours.
Thank you very much. Let me just hit play here, and with any luck, you will all see my presentation.
We can see it.
Excellent, thank you. So I'm here to talk about automated firewall testing. I've already been introduced, so I'll skip this bit. I'll mostly skip this bit. I will blatantly abuse this conference to advertise my own conference. This conference is nice. EuroBSD is nearly as nice as this conference. You should all keep an eye on our website to see when and what and how things will happen. We're still very much hoping that we can make it to Vienna this year. If not, we will have to follow your example and do an online conference. But moving straight on to PF. Peter, in the previous presentation, has already talked about PF. That is the BSD packet filter, so the firewall. We blatantly stole, I mean imported it from OpenBSD some time ago. So the two versions have drifted apart from each other slightly. So OpenBSD has a bunch of shiny new features that we don't have in FreeBSD, but in FreeBSD we do have some shiny features that we have in OpenBSD. One of which is VNet, and you'll hear more about VNet later in the presentation. Another one is that the FreeBSD network stack and PF implementation scale better across multiple cores than the OpenBSD version. So ours makes mistakes faster than the OpenBSD version can make mistakes, or something like that. Anyway, moving on. We're here to talk about automated testing. So I should probably try to persuade you that automated testing is a good thing and explain why we should automatically test things. And it's not just because I find testing to be really boring and I'd rather be doing other things. There are any number of laid videos on YouTube that I haven't watched yet, so clearly I'd rather be doing that than manually testing things. Why do we test? Well, sure that things actually work, obviously. Why do we do that automatically? Because I don't know about you, but I'm really lazy. And it also means that, you know, when we have automated tests, we're much more likely to run those test cases. That means that we will notice when things break, or that we can have things like sanity checks while we're making changes. I'll have a story about that later, I hope. Speaking of regressions, I have a good example of regressions. One of the things I did to PF early on when I started maintaining it was teach it about IPv6 fragments. I have an entire rant about fragmentation. I'll save you that. But a while ago, in fact, nearly 4 years ago, in December 12th of 2016, we accidentally broke IPv6 fragment handling in FreeBSD, only on the fast path. And who cares about fast packet forwarding, really? It turns out that it took us 9 months to discover this bug and fix it. Fixed October 25th, 2017. For those who care, it was an order of operations problem where we checked the packet size for the firewall, which broke PF's ability to reassemble and refragment things. I've honestly forgotten the details. But 9 months to discover a bug and fix it is kind of bad. I will joke about throw this code to the users and they'll shout when it's broken, but I kind of prefer it when users don't shout. I think users prefer it when things are not broken. I think. But anyway, making the case that testing is good, we broke IPv6 fragmentation again. I swear this is not deliberate. Anyway, someone fixed a vulnerability. My recollection of that vulnerability is that was a resource exhaustion attack where you could generate IPv6 fragments and send them at a firewall or a destination host in such a way that it would trigger worst case behavior of the algorithms used to do the reassembly, and you could exhaust CPU power on a target system. Kind of bad. So someone fixed this, which is awesome. Unfortunately, they kind of broke IPv6 reassembly in the process, which caused the PF automated tests to fail. We didn't immediately fix the problem. It took 2 weeks. But I'm sure that you all agree that 2 weeks is a shorter period of time than 9 months. And that is a significantly better way we're in a significantly better condition if we find bugs after 2 weeks rather than after 9 months. For additional fun, this was a Heisenberg. Trying to observe it changed it. So while detracing it, trying to figure out why it was broken, just stopped being broken. Not really tell our users to, start this detrace probe and your problem will go away. So I did kind of have to figure out what the problem was. And because it was a fun one, I'm going to give you all the chance to try to find the bug as well. Here's the relevant code. I've stripped out all of the bits that are not relevant. So why don't you all have a quick try to see if you can find the bug. If I did that right, you all just heard Jeopardy music. If you didn't, pretend that you heard Jeopardy music. I can't actually see you all raising your hand, point out where the bug is. So I'll just point it out for you. What we do in this code is we hash the IPv6 source and destination address as well as the identifier, which we use to find related fragments of this packet. That's great, but when we do this, we copy the IPv6 source to hash key, we copy the IPv6 destination to hash key, we copy the identifier to hash key, and then we hash over the entire size of the hash key. Hash key is size of IPv6 address plus the identifier. That's all super. Problem with that is the size of an IPv6 address is 128 bits. So number of bytes, 16 bytes. But we're taking 16 uint32s, which are 4 bytes each. So 16 times 2 times 4. So our hash key is actually much larger than the data we copy into it. And then we hash over all of that data. So we get arbitrary information in our hash key. Arbitrary information that in this case turns out to be, whatever happened to have been left on the stack, which is non-deterministic in usual operation. But when you have a dtrace probe that fires when you enter this function, then it turns out your stack information is deterministic. your different fragments of the packet hash into the same bucket, and your reassembly just works. Great that we understand it, but clearly we can't actually, do dtrace as a permanent fix. So this is the patch that went in. We have to divide our size of these relevant things by uint 32t, and then we end up with the correct number of bytes to hash. So these bugs can actually be really subtle. It's actually really easy to miss a bug like this, even during code review. So it's really nice when we can find them automatically. What we want from these tests is, well, I've already pointed out that I'm lazy, so I want them to be easy to write. I want them to be easy for people to run so that they run those tests before they commit things. Because what's better than finding a bug 2 weeks after it's introduced? Clearly, that is not committing the bug in the first place. If it's easy for people to run these tests, hopefully they will, and they will notice their bugs before they commit changes. We also want them to be fast to run because, aside from lazy, we're also really impatient. And ideally, we'd also like them to integrate the automated testing framework that FreeBSD has obtained after one dark night. NetBSD left their garage unlocked, and we rummaged around and found the testing framework. That integration means that we run those tests automatically on the FreeBSD CI cluster, which runs Jenkins. We'll see test results. This one was probably a while ago. 7,300 different tests, of which 2 failed. Numbers will always be different, of course. But we will keep an eye on, do things actually work? The specific case that I'm interested in is a firewall, and firewalls are, a lot harder to test than LS, because how would you naively automatically test a firewall? Well, you want to send packets from A to B, see what comes back. So you want a server, a switch, a server, or possibly you want a forward packet, so server, switch, server, switch, server, VLAN capable switch, and then you can reuse the switch. But we have even more advanced features in PF. PF sync, which synchronizes state from one host to the other, so you can have a failover between them. Need server, switch, server, server, switch, and server. And it's kind of a lot of hardware. Not only does it become a lot of hardware, it's firewall. One of the things we like to do is block packets. And if you want to SSH into the machine to configure the firewall, that becomes kind of problematic. I'm sure that at some point we've all done this. I know I've done this. Configure a firewall host. First thing you do is, okay, drop all packets. Does my SSH connection stop responding? Oh, yes, of course, we've dropped all packets. Happily, when I did it, I was 20 meters away from the machine, and a quick power cycle fixed the problem. It happens to us all, and it's kind of annoying when we do it in tests. So also when we have physical machines installed with FreeBSD, what version are we testing? Net boot them, but well, a network file system dropping all packets, your kernel tends to become unhappy when its root file system goes away. It panics, you need to power cycle the box. You also want to see what sort of panic messages it kicked out, so this becomes difficult. It fails on the easy to run, it fails on the fast to run, it fails on, everyone can run this. A slightly better approach might be virtualize this setup. FreeBSD has Beehive, has a virtualization system. A GSOC student took this approach back in 2017. It's better, but still if we drop traffic, so we have to do operations through the serial port rather than SSH, we can't easily nest virtual machines, which is annoying because the automated tests run in a virtual machine. Building a full virtual machine takes a lot of time. When it panics, it's still annoying. It's also slow to run. So what we want is something even better. And it turns out we can have that. One shiny feature that FreeBSD has is called VNet, sometimes vImage, virtual network stack. associate them with jails. In case you don't know what a jail is essentially a CH root on steroids. Not only limits you to a certain subsection of the file system, it looks as root to whatever process is inside there. It also limits your visibility of processes that are running outside of the jail. And from FreeBSD 12.0 onwards, you can configure that jail to have its own IP stack. So it can have its own IP address completely independent of the host's IP stack. And you can even configure your firewall in this jail. So you can have what is essentially a virtual machine at the cost of jail, a CH root, which is basically cost of a process. Possibly multiple processes if you run multiple processes in your jail. It's very similar to the container system that Linux has, except I promise you this is a lot easier to set up. You may be worried that this is difficult to create, but actually this is how you create a VNet-capable jail on FreeBSD. Sudo, because you need to be root to create a jail. Use jail for the jail command, -c for create. Equals Alcatraz sets the name of the jail. I think that's funny. You may disagree. You might be right. I tend to name my jails after jails. But to be VNet capable and persist merely tells the jail that I want to stick around even if there are no processes in this jail. Without VNet, that doesn't make a lot of sense. You can actually have a firewall jail that doesn't have any processes running in it. Obviously, we don't yet have network interfaces, so if you want to actually make use of this virtual network stack, we need to put an interface in it. A convenient way to do this, and the typical way that we do it for tests, is we use e-pairs. E-pairs are virtual network interfaces. So you create an e-pair, and what you get is two network interfaces with an invisible wire between them. E-pair, every packet you insert in e-pair 0A is out of e-pair 0B, the other way around. So we can assign an IP address to one of those interfaces, and then we can create a jail, same as we've seen before. Jail-c, name Alcatraz, VNet, persist, and then we tell it VNet interface. So one interface that you have in this jail is ePair 0B. Now the ePair 0B interface will appear from the host, but will be visible inside the jail. And we can execute commands inside that jail. For example, jexec to execute a command in the jail. They're missing the name of the jail, so what it needs to be is sudo jexec alcatraz ifconfig epair 0b an IP address up the interface. Now we have an interface to the jail. We can ping it. One ping only to that jail. Obviously, this doesn't test the firewall, but it does actually test a remarkable amount of setup and tear down code in our network stack. So that all by itself is useful. Let's now actually use these features for a quick and easy test. This is a very this is the start of a very basic pass block test for IPv4 traffic. What we have is we source utils.subr, which is utility subroutines. You'll see some of them. We define a test case named v4. We point out that there is a v4 underscore cleanup function that needs to be called when we're done to clean up whatever we've created. The head of the function sets a description and points to the test system that you need to be root to run this test. So that means that if you try to run the test suite without being root, it will just skip the test. You can also set things like, I need this particular tool. A lot of PF tests need Scapy, which is a Python library for packet manipulation, so that we can do things like create corrupted packets and see how the firewall responds to that. We don't need this for this particular test, so we don't list it. So what do we do? This is the actual test body. So this is basically all that there is to writing this. Everything else is boilerplate, and you can just copy-paste from another test and change some names. So what we do is we source utils.subr, which is utility subroutines. You'll see some of them. We define a test case named v4. We point out that there is a v4 underscore cleanup function that needs to be called when we're done to clean up whatever we've created. The head of the function sets a description and points to the test system that you need to be root to run this test. So that means that if you try to run the test suite without being root, it will just skip the test. You can also set things like, I need this particular tool. A lot of PF tests need Scapy, which is a Python library for packet manipulation, so that we can do things like create corrupted packets and see how the firewall responds to that. We don't need this for this particular test, so we don't list it. So what do? This is the actual test body. So this is basically all that there is to writing this. Everything else is boilerplate, and you can just copy-paste from another test and change some names. So PFT init, initialize the PF test framework. Basically what this does is it ensures that you've actually got the PF module loaded. Not really test a firewall when your kernel doesn't contain the firewall functionality. Pair PFT MK ePair, so we create an ePair interface and we store the base of the name in the ePair variable. On general theory that ePair 0A only can only be created if it doesn't already exist, and if we hardcode names, that's just going to break if those names are already in use. So we create an interface, we give it an IP address, we PFT MK jail, so we create a jail, we call it Alcatraz, we immediately give it an interface, we configure an IP address in that interface, and we do a basic sanity check, ATF check. So that's essentially the test framework that I'm executing a test. If this fails, that is if it does not return exit status 0, then fail the test here and report the test case as failed. -o ignore to tell it to ignore the output of the ping command because you kind of don't care what it outputs as long as it returns exit status 0. Next operation, we enable PF in the jail. Default PF will allow, if it does not have any rules, PF allows all traffic. So we load PF and we make sure that we can still pass traffic. And then we set a very simple rule, that is block all inbound traffic. Which, doesn't make your host particularly useful, but it's a useful sanity check to say, hey, does my firewall actually do something? We again send a ping message to jail. This time we expect exit status 2, because ping, when it times out and does not receive a reply, will return exit status 2. So in this case, the test framework will expect an exit status of 2, and if the ping succeeds, for example, because setting the rule failed, or there's a bug in PF that causes it to not actually drop packets that it should be dropping, this test case will fail and we'll know about it. Some cleanup boilerplates. The PFT cleanup will remove any jail that was an interface that was created as part of the test. And then we need to list the test as a case. So when we run this, the QA test pass block v4 runs, it takes 1.2 seconds. I think we've achieved our fast to run requirement. Also turns out to be relatively easy to do things this way. So it's fairly easy to write tests like this. I have, for specific test cases, wound up writing tests in about 15 minutes. Harder setups sometimes take more time. We can give you an example of a more complicated test. Skip all of the boilerplate. Here's just the body of it. This is a test for PF sync, which I think I've already mentioned. It synchronizes firewall states between hosts so that you can take down one host and have the other one take over traffic. You would combine this with CARP, that you have a single IP address that floats between those two hosts, but leaving that entirely aside, this would require, well, a minimum of 4 machines to test if you did it with physical hardware. But we're just going to do it with our hosts and two jails. Create additional jails to be source and destination of traffic, but it turns out we can just use our host to do this. Create a sync interface. That's the interface that the jails will use to synchronize states between them. And then we have one interface to the first jail, another interface to the second jail. We set up IP configuration for them. We configure the synchronization interface so that they synchronize. Pretty boilerplate stuff. We enable PF on both of them. We give them the same rule set. We tell them, skip firewalling your synchronization interface, because if you drop the synchronization traffic, obviously you're not going to synchronize state. We can configure the interface, and then we can send a ping message to one of the jails, and then check that the other one has the state on it. So essentially, we create state on one jail, with a little bit of time to synchronize, then we check that the other a jail has achieved this, learned about this state. A relatively complicated concept and setup. I'm sure you'll agree that this is very little test code. If you're interested in what these tests look like, FreeBSD system that has a source code, you can go to user source test sys netpfill pf. That's where the test source code lives. They live when installed under user test sys netpfill pf. There are much more tests, of course, for pf as well as for other bits of the network stack, for other utilities. Running them, install 2 packages. Actually, this is slightly outdated. QA is now part of the base system, so you no longer need to install it. Installing Scapy is optional. You really only need it for certain tests, not for all of them. The pf sync module, which depends on pf, so will automatically load pf as a prerequisite to that. Go to directory QA test, ideally as root. If you want more information about this, and I'm sure you're all seriously interested in this, there is an article in the FreeBSD journal, the March-April 29 edition. You can find on freebsdfoundation.org/journal. The FreeBSD journal is free to read, so there's nothing to stop you. Just take a look at it. Go read the journal. There's an article on how to write tests with a little bit more detail than this presentation. That I've convinced you the tests are good. I would usually put an authoritative quote there. Unfortunately, I don't have one, so we'll just keep it seriously. Write tests. Tests are good. So really awesome. What's in it for you is you can use this to prototype setups. You don't even need to do this as part of a test framework, but you could use VNet to prototype, to experiment with things like, hey, I want to test out CARP, I want to test out PF sync, and I don't have 3 or 4 random machines lying around to connect to each other and to test this on. You can do this with jails on your single system. You can run that in virtualization, fast enough, works just great. Another reason why you might want to write a test case is you have a specific use case. You would like to make sure that developers don't accidentally break this during development. You don't do this deliberately, not usually, but sometimes bugs happen. And it would be, if you have a deployment that depends on a very specific PF feature, for example, it might be useful to write a test case for this to make sure that we don't accidentally break it. Because that's something that might block an upgrade or crop up at the most inconvenient time. So write a test case and make sure that it doesn't happen. Or if it's already happened, write a test case, demonstrate to me or to another maintainer that, hey, there's a problem here. You do this, it breaks. And there are many reasons why this is extremely helpful. One of which is that I'm lazy. I'm not going to lie about it. I'm lazy. And if you write the test case, you've done actually more than half of the actual work involved fixing a bug. Quite often I spend more time on reading a bug report, asking questions, trying to understand what the test setup is, trying to reproduce it locally, than I do on actually fixing the bug. If you write a test case, there is very little scope for misunderstanding. I can see what you did, I can see where it explodes, I can reproduce it locally. You've done more than half of the work involved in getting the bug fixed. It is honestly often easier for me to fix a bug myself when I have a test case than it is to review the patch, make sure that I understand it, and merge it. I have to write the test anyway. If you write the test for me, it's awesome. Even more awesome, of course, is that you write the test and the fix and send them to me, because then I have to do very little work at all and see the first point. Pointed out where you can find the PF tests. There are some other tests. You won't be the first person to see to write tests. One of which is the IPsec stack. One of our developers was very tired of IPsec always being broken. So he wrote tests for it. Now IPsec is not always broken. And when it does break, Li Yuan, who is in charge of the continuous integration and automated testing project, he will shout at them. He won't actually shout at them. He's a very nice man. He will politely ask people to fix it, but the effect is generally the same. There are tests for the bridge, for the DUN interface, for VLAN, for CARP. I think the VLAN test is extremely basic because I wrote that test as an example to someone else of how simple it is to write tests. While I was writing the tests, I discovered the kernel panic. So it took a bit longer to write the test because I found an actual bug writing it. I wrote tests for IF Bridge because I recently-ish did a project on bridge performance improvement. And it turned out to be extremely useful to have cases that exercised some of the common functionality. Because during the performance project, I was messing with locking and changing locks, changing the order in which we took locks, changing the type of locks that we took. And that combined with the witness system and judicious use of assertions throughout the code meant that I ran into quite a number of different panics doing this, but I always found them very quickly. And I found very few issues after I actually merged the patch for this. Other people wrote redirects, divert, IPv6 fragmentation tests for the network stack. So there are a bunch of tests already in there, and they are extremely useful in making sure that things work and stay working. I think we're nearly at the moment where it's time for questions. I will put up the feedback slide where you can give your feedback on this presentation. But in the meantime, I think we have time for questions. I'll put it to our heralds to inform me of the questions, please, and I will do the very best I can to answer them.
So I can't see any questions. We had a problem with this question form in our site. For now, questions can be answered on YouTube or Facebook if you wish. But for now, I don't see any questions.
All right. I'm sure my contact information will be shared through the feedback form. So if you have questions later, feel free to ambush me there. I'll go and try to find the YouTube page and see if I can answer some questions there after this.
So we have a room called Philharmonia on our site. You can join after the presentation to have online chat with.
Excellent. That works as well.
And thank you very much for attending OpenFest 2020. It was great pleasure for us. And
thank you for having me. OpenFest is on my list of conferences I want to visit. Been to Sofia a while ago when one of your co-organizers organized EuroBSD there, and I really quite enjoyed it. Kind of hoping to make it back at some point.
Thank you very much. And now we will have 1 hour lunch break. After that, we will continue that session. Thank you.
Thank you. Let me figure out how I can stop sharing my screen and my microphone here. There we go. Stop screen share, stop webcam.
Welcome back. I hope you've had a delicious lunch and that now you're ready to listen to our next speaker, Andrew. He's working as a Ruby developer, and I'm told he's very happy to be one. But lately, he's been teaching Rust in Sofia University, and he likes static typing more and more. He's here to tell us more about it in his talk, The Freedom of Static Typing. Andrew, the stage is yours.
Thanks, Yulia. Give me just a sec to launch my presentation here. And let's do some screen sharing. All right, let's see now. Hello, everybody. My name is Andrew, as Yulia pointed out. You can find me all around the internet as Andrew Radev, GitHub, Twitter, whatever. And if you have trouble with the last name, just remember it starts with rad and it ends in dev, and a radical developer is what I am. Today, I'd like to talk about static typing, particularly in Rust. And this talk was inspired by a different talk I saw back in the day that was about Haskell and about similar languages, like similar static typing languages. I was very excited. This was at the Ruby user group. And so the whole audience was Ruby developers, and I was hoping that they're going to show us some cool stuff to do in static type languages, like magic event loops into infinite lists and return type polymorphism, and a bunch of monads as usual. I was kind of disappointed actually at the talk because it was mostly about Ruby's failings instead. It was all about how in Ruby we have all these runtime errors and new pointer errors like all the time. It's generally so difficult to deal with this. We were swamped with errors, and there was an undercurrent in this talk. I felt that our language, this language that we've picked, it just has too much freedom. It allows us to do too much stuff, and we can't be trusted with it. And I didn't. This was not the direction that I was thinking that this was going to take. Now, listen, I've been writing Ruby for a long time, and I'm here to say it's not that bad. A bold statement. I realize the hardest of takes. It's not that bad, but yeah, sure, we do have the occasional runtime error. We do have a bunch of nils here and there, and that's why we have a lot of processes and tools to try to avoid this kind of thing. We do a lot of peer review. We have a lot of error tracking in production, which I think is a good idea, whatever kind of language you're using, really. In general, we don't we don't actively try to get runtime errors. We think things through and try to write sensible structured code. When I was learning Ruby, somebody asked the teacher, like, well, this whole dynamic typing thing, what if I have a function that takes a dog, and then what if I give it a cat instead? What happens then? And the teacher said, don't do that, I guess. So don't do something that is going to be wrong is generally some pretty good advice. Having said that, sure, sometimes there are language features that cause errors that it would be better to fix the the language problem, change the language design rather than to keep telling people just use it in this particular way and you won't get hurt. And Rust was built in part to solve one of these kind of problems, to sort of create an alternative for a language that is notorious for some of its memory unsafety and difficulties in running safe code. And so I can sort of understand how a lot of discourse in when it comes to Rust is built on top of this idea of safety. And I feel that this sort of brings us to the point where it feels as if this static typing is just this kind of limitation that we need to have in order to protect us from ourselves. And I don't, it's not false. I don't disagree with this exactly. But I think it's a very negative viewpoint on static typing to sort of say, no, you don't get freedom, right? You have to be put in your place. I think that static typing does give you a lot of freedom in a different kind of way, that it actually allows you to do things that you might not be able to do in a dynamically typed language. And I would like to talk about it in this way, from this perspective. Pick on positive examples why you would want to write in a statically typed language, why would you choose to do that in order to express yourself better in at least some ways. And the first example I want to talk about is something very basic. It's the enum, or as it's called in other languages like algebraic data types, sum types. In general, these are all like much cooler names. I love them a lot, but we're sort of saddled with enum for, I think, C compatibility. And the basic enum kind of looks like what you might see in C. You've got the type name, which in this case is weekday, and you've got the individual variants of that enum. So it can be one of these things. It gets a bit more interesting when we add actual data to these variants. This is something we can do. Rest allows us to do that. And so we can have the type IP address that has two variants, v4 and v6, and we can construct a value of that type, of that enum, in this way. Right? This is how we address it. This is how we provide the data, like the data package. And two of the most fundamental enums in Rust that sort of are used all over the language are option and result. And I want to talk a bit more about those. Option is very simple. It has two variants. One is sum with some sort of a value, and packages up some sort of value of a generic type, so any kind of type that you want. And none, which indicates that there is nothing here. So this is in a way a replacement for null, but it's a better replacement in some way. How would we use it? Well, if we have, let's say, a vector and we want to get one of the elements of the vector, this is how I might do it, called the get method, and that returns an option of whatever type the vector is in. So we can get a sum with the actual value, or none, which means there's nothing there. Now, we actually want to use this value, though, usually, right? And it is now packaged in sum, if it is there. So we do have to do something about it. And the most fundamental way, sort of the most basic way of managing this is by using a match statement, which takes some sort of an expression, and it pattern matches the results of the expression with where it evaluates to. And in the case of enum, we can go over the different variants of the enum and say, if it's this, do that. If it's this, do that. In this case, it's sum, and then it has some sort of a value inside it. The value variable is going to be bound to that internal value in the right-hand side of the match statement. And so that gives us the ability to sort of fork our code and only do things. And if we don't care about the none case, we can actually just unpack it with an if-let statement. If this at the right-hand side, match side, then we can safely define the value variable within this little block, and we can use it in there, which is really cool because apart from actually checking if the value is there, it also gives us the value in one go, which is kind of cool. It sort of does not require you to do two separate checks, one for the check, one for the for actually getting it. The result is slightly more complicated. It has an OK variant, which indicates a successful result of an operation. And it has an error variant, which indicates sort of an error. And it has two generic types because it can have, it has two different things that it can contain. And the way to use the result, well, you can use, let's say, a standard library read the string function, which takes some sort of a path, and it returns a result of either the string contents or an IO error. The same way with pattern matching or whatever. What I think is an interesting question here is, why is it one value that we return as opposed to, for example, two values? Because this is something that I've seen in other languages. You might get a tuple as a result, which has either a setting or an error, or it might not be a pair of elements. It might be a pair of elements that is not a tuple technically, but I've seen this in other languages. And it could work like this. This is not real, by the way. If nothing else, there's no null in Rust, so we can't really encode the error, but we could come up with something. But there is at least one interesting benefit for having one value as a result, one enum, and that is that we can actually define methods on enums. And so let's say we have this read settings function, which is basically read the string, except I need to adjust the data type a bit. But you have a read settings function that returns the string content of this file, right? So what you can do is, what if this doesn't exist? Well, you can do is you can call a function, a method on this value, or else. It takes an anonymous function, it takes some code, and if the result is an error variant, it calls the result, it gets a result from that, and then it passes that new result along the chain. And if the result was successful, it's going to immediately pass it along the chain without calling this function. So this allows us to basically try to read this file, settings.json, and then if that fails, try to read the other file, config.setting.json. If either one of these succeeds, the end-then function is going to call its given code, its given callback with the internal JSON value, and then we can call this other function, parse settings, that expects this string, and it returns something else, right, with a compatible error type. And then from that point on, we can call unwrap or else, which is either going to return the actual internal value, or it's going to fall back to calling this settings default. So this, these 4 lines, they actually do a lot of work. And if you're a fan of this kind of functional style of chaining method calls, you might like this. If you're not a fan, that's actually kind of fine. There's other ways to deal with error handling in Rust, and we're going to see one of them a bit later. The fact that you can do this, the fact that you can define these methods, and these methods encapsulate the pattern matching, mean that you don't need to fork your code to implement pattern matching or if clauses. You can have these chains of methods and sort of encapsulate this logic in a single place, which is really kind of convenient. And it's not really that great of an option, that much of an option when you have 2 values as a result. Now, do we actually need an enum for that? Because in Ruby, for example, we might be able to define a result class that takes a value and an error. This works. We don't really need an enum. We can define and then and or else methods that work pretty much the same way. And then it's going to say, well, if we have a value, a non-null value, then call the block that you've been given, right? If in the or else case, we do the same thing, except we check the error, right? So if there's an error, call the block with that error, right? And then return that. We could do that, and if we do that, well, here's how we might construct a successful result. Here's how we might end an errorful result with a value or with an error. That works. We can then do the whole chaining thing, or else, and then sure, why not? That will work. But what happens if we have both a value and an error? Is this possible? Is this sensible? Does it fit our internal model of how this is supposed to work? And then checks for a value, or else checks for an error. What if they're both there? Do we expect that either one or the other is going to be called? It depends on how we've written it, sort of, right? We could add runtime checks, or we could add something like raise an exception if you have both a value and an error. That could work, right? This is one way to enforce this kind of thing. But it can get more complicated when we have a more complicated setup of, let's say, some sort of an event that can be multiple different types of an event. And it can have a different subset of data depending on the type. Some of these can be null, some of these cannot be null. We need to think all the time about if clauses here and there in the method calls. And this can get can be a lot easier if you have an enum, because you are actually encoding this idea that you have different types of of an event that have different packages of data. This is what an enum gives you. Most types, I'm hesitant to say all types, but let's say most types are some sort of a container, right? Whether you have a class or like a like a tuple or a dictionary, you have some data in memory, and your type sort of encapsulated it. It wraps it up in some kind of a structure, in some kind of a shape. But all the data is there, right? It's a container for the data. Whereas an enum is something slightly different. It doesn't just hold your data. It also allows you to express exclusivity, to express that it's either one of these things or the other thing. And it feels like there's nothing stopping us from defining it in a dynamically typed language. Remember that I am sort of talking about static typing here, but the thing is, it doesn't fit the philosophy, I think, of most dynamically typed languages to actually do this. In Ruby, for example, we don't need an enum to have 2 different types. Of success and error, these in these classes, and just use them interchangeably. This is duck typing. This is a very standard thing to do in Ruby, and it's a very sort of common thing in terms of philosophy, right? you're expected to pass along these types, respond to particular methods instead of building interfaces or trying to enforce certain structure. Right? As long as it responds to a method, you should be able to pass it along. And this is perfectly standard. And the problem, well, let's say something very specific about it is that this is implicit knowledge. You need to be aware that success and error have the same methods in order to be able to do this kind of thing. Same thing can be said for the result having a value or an error. This is something you know, maybe because you read it in a comment, maybe because you consider it as a common sense thing, but it is implicit. It's not encoded in the actual language. Whereas this is what you get from aesthetically. Open up a bracket here to say that this is not necessarily a bad thing. Like, this is not a bug with dynamically typed languages. This is a part of their philosophy. In a lot of cases, you just have things that can be considered common sense. And by common sense, I don't mean like universal to the human experience. I mean common in terms of you all in the team already understand this. All of you that work on this code base have an idea of how you're supposed to be using it. You see examples, you can see tests that use this code in particular ways and might describe these kind of ideas. You don't need them, you don't need to keep writing them up here and there and in every other place. This also means that some of these rules can be much richer than the type system allows you to describe. You can put a lot of information, a lot of text in a comment written down in English. A lot more nuance than you might be able to express in a potentially complicated, compiler macro or something like that. And it can be much easier to move on from one rule to a different set of rules. For instance, I did say that a result should only have a value or an error, right? But why should it? We could have some sort of a result that accumulates values and errors from some sort of a complicated process that produces separate results. And then we still have a result, and it still has a value and an error, and we still have access to its properties. Except, maybe we would need to limit ourselves in its usage and don't rely on and then or else because it will be a bit undefined. It might not be the perfect solution for this situation. Maybe there's a different abstraction that we can use, but the important thing is that we can use this for the moment as a sort of temporary step, as a sort of patch of the rules of the loose rules that we have in our application. This is a feature and not a bug. Although it is admittedly something that could cause some technical debt. So this is something to be careful of. Speaking of things to be careful of, and also of patching, I do want to talk about monkey patching now. Well, as other people like to call it, freedom patching. Other people mean DHH. Never mind. Monkey patching is a really cool dynamic typing feature. It allows you to take some code that has some sort of a method and then just sort of reopen this class and then redefine the methods, right? To patch this class to have a different implementation of this method. And this can be very useful for testing. It essentially means that stubbing is absolutely trivial, stubbing some sort of a method out, some sort of an external client. It could be useful for security fixes. It could be useful to just make small tweaks to some library because you can't quite update right now, right yet. It could be very useful. It could be very powerful, and it could also be used for some clever tricks, like you can reopen in Ruby. You can reopen the true class, which is the class of the value true, the Boolean value true, and you can define methods if true and if false. And if true is going to call this given code, and if false is not, right? It's just going to do nothing. And in the false class, we go the other way around, right? And so if we have a Boolean expression which is either true or false, and these if true and if false methods are going to get called on the right class, and and they're gonna run. And so you get this kind of postfix if operator that if statement that looks like some sort of a built-in native. And in fact, in Smalltalk, this is how you write if clauses. And if you want, you can just implement it in Ruby. You can just extend the language to make something that looks as if it's native syntax. This is the power of dynamic typing. This is the power that you get from this kind of flexible, dynamically typed language. Although having said that, in Rust, you can define a trait. And a trait, kind of like an interface, right? And you can implement that trait for the built-in bool type. This is an option. You can do this. And you can define if true and if false methods, and then you get, guess what, the exact same thing. You can call if true as a method call. You get the lambda function, probably even slightly faster, but that's a different topic. You probably not a whole lot of performance in this kind of thing. But it is something you can do without needing any kind of dynamic magic, any kind of runtime sorcery. This all happens compile time, and it works. Rust gives you this option, even though it's so strongly selected type. You can actually change, built-in types. Sort of. This is not monkey patching. It's important to know this. It's basically just extending core types with new methods. You are not allowed to override existing methods. That doesn't work. You are also not allowed to change the state of this structure. This is not a class. You can't really sort of add new fields to it or anything like that. But these limitations do give you something very, very powerful. They give you modularity. Ruby has had this problem for so long. If you require some sort of library that patches a built-in type, a core extension, you can get some really cool stuff. Like you can get a pluralized method on string, which is very readable, which is very convenient. It chains up really nicely. It looks like a sort of a native thing. But the moment you do that, this pluralized method is now in all strings anywhere. And if anybody requires your code, so if you distribute this in the library, everybody gets this now. Right? Even if they don't want that, and it's going to be a pretty big surprise. It can cause conflicts. It's not great. It's not something you should do. Really, you can use it in applications. You should not distribute it in a library ever. There's a possible solution in refinements. I'm not going to go too much into it. Unfortunately, it's not that commonly used. Rust solved this problem trivially, because the moment you call use, which is just the standard way of importing things and taking the scope, you can get these methods, and use it the same way. This inflector package is admittedly not as well maintained as the Ruby variant of it, the Ruby version of it, but it is there. It works. You can do it yourself if you want, and you can take this code and you can distribute it anywhere as a library. Anybody can include it, and you're not mutating any global types. You're not doing anything bad. This use statement is only affecting your current module, or it can even affect a smaller scope if you wanted to. Usually unnecessary, but yeah, unless you re-export it, it's going to be there, and even then somebody has to re-import it. And this is really powerful. This gives you the ability to distribute your code to make these kind of tools and ship them and sort of ship these extensions to anybody that wants them. And this is a bit of a toy example. So this is how it looks like. It basically, the method calls simply desugar two function calls that follow the standard visibility rules of Rust. So this is a bit of a toy example, but here's a package called itertools, very convenient, that implements this kind of core extension. In Rust, there's a trait, an interface called iterator. And when you say something like, we have a string, you call .chars on it, you get a concrete type called chars, structure called chars, and that structure implements the iterator trait, so it implements iteration on the characters of the string, and bytes implements the same interface, except it implements it in a different way, so you get a different kind of iteration, and you have all of these structures in the standard library into values for a hash map that implement the same interface and have the same methods. It's all very consistent, very sensible. And what itertools does is, and this is literally a line in the actual library, it's literally taken from the library. Where it goes is, it says, for all the types T that implement the trait iterator, just all of them that exist, that are visible right now, almost all of them, but ignore this part. For all of these types, also implement the itertools trait, right? And by doing this, it means that the moment you include itertools in your code, what you can do is you can take a string, you can break it down by characters, or iterate it by characters, chunk it into 7 character chunks, intersperse these with little pipe characters, intersperse the rows with with separators, join them up on new lines, and now you got chunky raisins in a table. And some of these methods are native. Map and collect come from the native iterator trait. and some of these come from iter2, so you get chunks, intersperse, and join. And it's not clearly obvious. It's not a different API. You're not using some sort of a different interface when using the standard library tools and the imported tools. And this is very powerful. You get this sort of chain of logic that looks as, it looks just the way it would if half of these were moved, into the standard library or moved out to an external package. You don't have extra function calls. You don't have any extra namespaces. You just have these methods that make sense on an iterator. And this is I think the thing that sort of connects monkey patching in Ruby and core types and core extensions in Rust. They give you the ability to create new extensions to the language that feel as if they are native, that feel as if they are part of the language itself. And some of these actually make it into the standard library. Ruby has a large history of extensions of people building these tools and these gems, these libraries that make it into the standard library, maybe at some point, or they make it in a different form. Rust has a bit of that as well. Although in Rust, this also happens due to macros. There's one very famous macro that made it into the standard library, and macros are not exactly a static typing thing in themselves. I think they're very interesting, but I'm not going to go too much into them. I do want to show you this particular macro because there's a very interesting static typing interaction with my next example. And so this is so I want to sort of do a crash course on this. First, we have some sort of a function. It doesn't matter what it returns in the successful case because this is about error handling. So it returns an IO error in the error case. And what can we do here? Well, what we do is we read some sort of a template to a string with pattern match, and we say, all right, if this is if we successfully read the string to its memory, we can assign this to the template variable. And if there's an error of some sort, of any sort, really what we want to do is just return this error packaged up in an error statement and just return it upwards so that it's handled by its caller. And we can do this for any kind of function, like for all these different files that we end up reading, right? The exact same code. So now we have some repetition. So how do we extract it? Well, we can use a macro. We can call this macro try because that's what it was called when it was built. It expects an expression, and this really is going to accept only a Rust expression, a valid Rust expression, not just tokens, not just a string. And what it does is it plugs this expression into a match clause, and it does exactly the same thing that we just did, except it extracts this with the expression being variable, right, being an input to the macro. And with that, we can reduce these blocks of code into a single line each. And each of these macros is going to syntactically expand at compile time into that above expression, with the expression variable being changed into whatever we've passed along. And so that means that if it fails, if there's an error, the return statement is going to return from the build HTML function. Because and this is why we use the macro, because if we used a function, that would return from the helper function, which is not what we're looking for. So this is very nice. This is very convenient. What happens if we have functions that return or expressions that return different error types? In this case, we have the read to string example, right? We're still reading something to string, but we might have some sort of a parse settings function that instead does not return an IO error. It instead returns some sort of a JSON parse error, right? And so in that case, what is this function going to return? What kind of error type is it going to return? It's not clear. It's not possible in Rust to do this, right? We have to return a concrete type. So what we can do in this case, the canonical thing to do really, is define a trait, which basically implements a conversion from an IO error into our custom error type app error, for example, right? And we can define the same trait for JSON parse error. And this defines a static sort of associated function from which takes as its input the source type, something of the source type, and returns something from the type it's implemented for the app error. And the way things work is having these implementations, what we can do is we can now return an app error from this function as a result type. And instead of returning error with the E variable, we package it up in this function called app error from E. This works, and this means that this expression now has the same type in both of these branches, because app error for me is polymorphic on its input, right? It's a different function based on what kind of type we provided, but it returns the same type of value. And now we can also fix the macro, right? Pull this logic again. So this time we have the app error in the macro. And this works this exact same way, but it introduces a little bit of a problem, right? This macro is useful and it's usable in our code, but it's not useful outside of it. It's not useful in a context where there's no app error identifier, right? And so if you want to, if you want to use this in a different package, you sort of have to re-implement it, or well, maybe we can parameterize about that, but that would make the interface a bit clumsier. There is a different way, which is why I'm explaining this for you. And it has to do with the last static typing feature that I want to go over, my favorite, return type polymorphism. Right? Imagine we have an article, it has a title and a body. We can construct an article and we implement a search function that checks the given article on a particular regex, checks the regex on top of this article, and checks the title, and checks the body, and it checks whether or not this article matches this regex. So we can have some sort of an article and we want to look for whether there's an email in this article. We say, here's the pattern, here's the regex that we built up. And then we say if we can find a regex there, and then we say, well, there's an email there, I guess. That's useful, but it would be more useful if you could get the actual email. We still want to keep the Boolean variant, right? We keep this function because it's going to be fast. It's going to be give us the ability to make a quick check. But we do want to also get some sort of a maybe search and get function. Find it and we get it. Is it going to be called find or match or well? There might be a good name to actually pick here, right? But the funny thing is we don't have to pick. We don't necessarily need to pick. Because what we can do is instead of defining the search function, the search method in the article as a method on article, we can implement and define it as in a trait, which is generically typed, and the generic type goes in the return value. This function is now not going to return a bool; it's going to return a generic type t. What does that mean? It means we can implement this trait for article once with the specialization, and now we can implement the same search function that returns a boolean. But we can also implement it another time with a different generic argument, and then implement a function called search that has the same inputs, but it has a different output, an option of string. And supposedly we're going to implement it in such a way that it returns the actual match if there is one. And we can do the same thing for a vector of strings, returning all the matches, which is going to be the slowest function that is going to give us the most information. And if we have this kind of this kind of example, now we can actually get 3 different outputs from the same function call. It's not the same function call calling different functions, but it is the exact same right-hand side. The only thing that varies is what kind of type we are requesting from that right-hand side. And we don't even have to explicitly specify it in some cases. If we say if input search, that's actually going to call the Boolean variant, because Rust is smart enough to know it's an if clause. What are you going to return? It expects a Boolean argument. If we use pattern matching, if that's some, that's going to call the option variant. For loops don't work as conveniently. That's probably because for loops desugar to something else anyway. There's a bit more complexity there. But this is still really, really cool. And again, this is a bit of a toy example. But let me show you a package, an external package that uses this, that relies on this functionality. It's called the package called Serde, and this stands for serialization and deserialization. And if you have a bunch of types, an article, a comment list, and a comment, individual comment, you can annotate these with compiler directives, which basically say automatically implement for this type the trait deserializable that comes from this package. And if you do that, well, what happens is you get some JSON string, some string in the form of a JSON. And you can actually say, give me an article from that string by calling the from string function. And this is a perfect generic name. It is, it's literally saying, give me something from this string. And what is that thing? Whatever we ask for. And I think this is magic. Like, this is just, it looks like magic. It blew my mind when I first encountered it. And I realized that, I mean, look at it. It's a function that has a perfectly generic name that returns, and this is coming from a package, and it returns your own type, whatever type you request. Now, once you dig into it and you think about how it works, it's actually not that surprising, is it? But I still think that it's very amazing that this actually works, and especially as someone who does a lot of dynamic, programming dynamic type languages, because you can't do that in a dynamic type language. In a dynamic type language, you can return whatever you want from a function because you don't have any specification for that. What you return from a function is not something you specify. It's not something you can specify. On the other hand, in a statically typed language, you can actually request a different type of result. You can specify that, and this is another fundamental difference between languages. A fundamental difference in what kind of freedoms they allow you, and this gives you an extra ability to express yourself when designing interfaces. You don't need to come up with two different functions, two different name functions. You can pick the same name if it makes sense, but vary the return type. It's an option. It is something you can do. And this brings us back to the error handling example. The right-hand side is the same, remember? Well, in this case, what we can do, what we used to be doing, is we're returning app error from E in the error case. Well, having this, treating IO error, JSON parse error, converting it to an app error. This is done using the from trait, which is implemented for source and target. Well, there's an into trait, which goes the other way around. And what it does is, for all the traits that already have an implementation for the from trait, what it does is it implements an extra method, which is return type polymorphic, and it returns, it just delegates to the from function coming from the from trait. This is a bit clumsy. Okay. And what that means in practice, you don't need to sort of try to analyze it and whatever. Like, what it means in practice is, instead of calling app error from E, we can always call E.into. What's the difference? Well, the difference is, instead of calling app error from E here, what we can do is we can call E.into. And this code, this macro here, is now perfectly generic. It has no mention of the concrete type app error that we are returning, that we are expecting to be returned. So how would this macro know what kind of type to return? How would this macro know what into is going to return? It knows because the function is annotated to return app error in the error case. And so this macro can only be compiled in this particular way. The into function is always going to be the one that returns app error. This is what you get from, and this is something that, because it's it's generic, it was able to be put into the standard library, and in fact, eventually evolved into the operator. Like, I don't know if you see the difference. There it is. Tiny difference, is a tiny, operator over there, but it does a lot of work. And once you figured out how it works, it is amazing. This is the power of return type polymorphism combined with macros. This means that you have a lot of control over the shape of the code, where you put annotations, where you put requirements, and you're not going to do a whole lot of this probably in your application code, but it allows library authors to do some really amazing things. It does end up being a bit too magical sometimes, to be fair, right? It can make it difficult to understand sometimes what is going on if you go overboard, right? GTK is one example of this. They had their reverse binding. They have like some functions that have optional arguments. To do that, they take an option of string. In this case, either you call it with some hello, or you call it with none. And how you implement this? Well, you just have the function that takes an option of string. Now, at some point, they implemented this functionality where you can just pass along a string or none. You can pass two different types. How? Well, you don't accept a specific type. You accept any type that implements a trait into option string, right? That same into trait that I showed you. And then you just go into and you get what you need. And the into implementation is automatic for optional values, because the way to construct an optional value is just wrap it in a sum, right? They went back on this feature. They wrote it back partially because they were getting some weird. It was more difficult to figure out error messages. Partly because they just wanted to be explicit, to be more explicit when writing REST code. And because that's the thing about these features. They give you a lot of freedom, but this means that they also give you the freedom to make mistakes, to go overboard when building these, magical return type interfaces. If you have a Schrodinger's cat function, you can say, well, it's generic. It returns anything in a box, and I can implement it for a living cat and for a dead cat. And so, depending on what I need, I can request the right, the right cat. That's not how the thought experiment goes, but work with me here. But what if you implement it so that it returns a dog instead? Well, I mean, I guess don't do that, right? That's the thing about about freedom. You can allow, this is it's sort of defined by you are able to use your freedom to express yourself in code. And the more freedom you have, the more ways there are to express yourself, and the more ways there are to go overboard and to write bad code. Because bad code is very context dependent, and it depends on choices, yours, your team's choices. You can have the freedom to return, whatever type you want from your function, or you can have the freedom to request a specific variant of the function based on the type. Either one or the other. It's not a one-dimensional thing. You can have the freedom to patch global types and fix security issues and have that propagate throughout your entire application. Or you can have the freedom to distribute your patches as actual libraries that other people can benefit from. You kind of can't have both. Oh, it's hard to have both. One way sort of limits you. In another way, limitations in one area give you freedom in another area. And the freedom you get in a dynamically typed language is easier to see, I think. It's a very simple kind of freedom. Return whatever you want, call this function whatever you want. And it is a freedom, and it is a powerful freedom, but it's not the only way to be free. It is still a trade-off. And I hope that, at least in the last 40 minutes or so, I've managed to show you at least a little bit of the freedom you have in a statically typed language as well. Thank you all very much for your time. I'm Andrew Radev. You can find me as Andrew Radev on internet, Twitter. You can type my name in YouTube to find screencasts mostly about Vim, entirely about Vim. You can see my blog, my blog on in the lower right-hand side. I am very proud of the domain name. It was not my idea, but I'm still very proud of it. The QR code is a feedback link. And now I'm giving the microphone back to Yulia here to help me out.
Thank you, Andrew. Thank you for the insight. I do believe that learning new programming languages and paradigms is crucial for becoming not just a better developer, but an outstanding one. So now we have some time for questions, actually. And let me remind you that you can ask your questions in any of the streamings in our social media channels, as well as on the openfest.org website. And unfortunately, I don't see any questions right now. And while we are waiting for some, maybe let me ask you our question, Andrew. So is there something in Rust that Ruby solves better, in your opinion?
Is there something in Rust that Ruby does better? Or,
yeah.
Oh, for sure. I mean, I do love myself some Ruby. I mean, what I said was, it's a very long topic, I think, to sort of go over. But really, to me, this kind of patching of rules, writing Ruby code means that it's a lot easier to sort of move from one state of the program to another, while also having sort of intermediate states that might not be the best, but it's a lot easier. In Rust, it often feels for me like if I'm doing some sort of refactoring or moving some code around, it's kind of like, in order to get it to compile, I need to do a lot of work to just, okay, move this here, what am I missing, okay, this thing. Compiler is helping, of course, the compiler helps a lot, but there's a bit of a, like a gap there that you feel like nothing is working, everything is breaking, and it's kind of hard to get through this point, right? Harder than it is in Ruby, because in Ruby you can more easily do this piece by piece. I've seen this also for homeworks, because as I said, I teach. Did I say it? I don't know. I teach a Rust course in Sofia University, and when it comes to homeworks, it's kind of like in Ruby homeworks, if you implement half the homework, you're still gonna get some points. In the Rust homework, if you implement half of it, you're gonna get 0 points because it doesn't compile. So there's ways around this. We give people the whole structure, and you can put unimplemented in some of these functions. But it really, it's easier to do things sort of half-baked in Ruby, and that can be both a benefit and a drawback, because you can leave them half-baked accidentally, but you can also sort of get them done piece by piece.
Thank you. I just want to let you know that we have a discussion room. So actually you can join it. It's called Philharmonia for this stream B.
Right.
So you can go there and also talk to other visitors. Also, you visitors talk to the speaker. And you can, of course, join the games of our sponsors. You can see more information about this on the openfest.org website. Thanks a lot, and see you in about 10 minutes for the next lecture.
Thank you. Bye-bye.
Чуваме ли се?
Здравейте, продължаваме с следващата лекция. Тук с нас е Исмаил.
Чуваме ли се?
Да, Исмаил, добре се чуваме.
Продължаваме с следващата лекция. Тук с нас е Исмаил. Да, Исмаил, добре се чуваме. Продължаваме с следващата лекция. Тук с нас е Исмаил.
Съвсем накратко, с Исмо се познаваме от доста време, покрай това, че и двамата сме Linux потребители. Исмаил също така е много активен член на WordPress обществото в България и често може да бъде видян на различни WordPress събития в страната и в чужбина. Тази година, за съжаление, ще бъде в този формат, в който трябва да се задоволяваме с лайв стриминг, но съм сигурен, че ще се получи пак интересно. Темата е важна за много хора, особено за хора, които имат зрителни проблеми. Исмаил, темата е твоя.
Здравейте! Надявам се да се виждаме, да се чуваме. Момент само. Здравейте! Надявам се всичко да бъде наред, да се виждаме, да се чуваме както трябва. Днес ще ви представя една нестандартна тема, която до сега не е представена на Word, на OpenFest. Сега аз съм член на OpenFest от доста време насам. Ще ви представя един екранен четец с отворен код, който аз използвам от няколко години насам, както забравих, че съществува. И надявам се на всеки да бъде полезна темата, както и за неговите софтуерни и веб проекти, така и за самия себе си. Аз твърдя, че веб достъпността и application достъпността трябва да бъде достъпна навсякъде за всички, защото хората, освен със зрителни и намалено зрение, имат нужда да използват веб и application и отворени продукти навсякъде, както намерят за добре. След малко ще споделя моята презентация. Сега само искам да попитам дали всичко се вижда, дали всичко е наред.
Да, виждаме презентацията.
Да. Презентацията ми е за един екранен четец от двама разработчици, които са напълно незрящи, които се запознават на един музикален фестивал, решават да направят един много готин безплатен четец, който е екранен. Който екранен четец представлява всичко, което излиза на дисплея и хората го виждат. Тези, които не може да го виждаме или не може да го възприемеме, да го чуваме. И аз именно на това се спрях на този проект, защото той е много готин и има много отворено комюнити към допринасяне за него. Следващия сайт NVDA е разработен за съжаление, само за Microsoft, аз съм им писал на пичовете, За съжаление, този проект е разработен само за Microsoftска операционна система, така наречения Windows. Като е направен да споделя и да използва Microsoft Word, Microsoft Excel, Outlook, Firefox, Google Chrome и основните неща. Както виждате, системните изисквания са много малко и много не толкова претенциозни, за разлика от платения JAWS for Windows, който струва 3000 лева и иска сумати пари и ресурси, за да може да ползваш крайния четец, както и браузър и дисплей и драйвери, за да бъдеш пълноценен на работното си място и в пълноценния си живот. Най-готиното на NVDA, който се превежда No Visual Desktop Access, е това, че позволява да се добавят към него разширения и добавки. Така наречените длани. Споделил съм сайта, който може да се отвори. Нали? Там може да се превежда на съответния език, да се добавят разни разширения към самия четец, което ще рече, че който разбира от Python, може да добавя съответните му нужди и за самата общност неща. Кодът е напълно отворен. NVDA е направен така, че се издържа направо от дарения. Покрай австралийското законодателство така е направен, че абсолютно е non-profit organization, но това не му пречи да бъде предпочитан за main тест на accessibility от Apple, Microsoft и Google. Тук съм споделил GitHub хранилищата на самия крайен четец. Там всеки може да се регистрира, да види pull request, push request, каквото може да бъде полезен. Това е интересното, че самия крайен четец, както и скъпия JAWS for Windows, както и Orca for GNOME, който и него ползвам време на време, те четат кода. Самите крайни четци, те четат самия код отдолу под операционната система. Тях не ги интересуват горе какви картинки има, каква графична среда, колко ти е шарен my документа и така нататък. Това е готиното на NVDA, за който аз го разбрах като мой основен крайен четец, що я позволява на хора като мен с нарушено намалено зрение, които виждат малко, да използват hover of mouse. Когато посочиш с мишката, където си по екрана на десктопа или на тъчскрина, самия крайен четец ти чете където си застанал, какво избираш и така нататък. Сега искам да споделя малко демо. В случая ще използвам английски глас, защото имам да покажа и как пиша код от време на време. Понеже много хора ми задават въпроса, добре, ти като си с нарушено зрение, като си с намалено зрение, кажи ми как пишеш код, как се справяш. Мисля, че OpenFest е времето, събитието, което трябва да покажа как девелопери и незрящи хора като мене се справят в такива ситуации. Ще си поделя екрана. Екрана в момента споделен ли?
Да, виждаме екрана.
Така, сега ще пуснем екранния четец.
Desktop list. NVDA 11 of 32. Desktop.
Звук чува ли се?
Да, идеално.
NVDA 11 of 32.
Екранните четци, както ето този.
Discord. Slack 23 of Spotted. Discord. Zoom 19.
Ето
JAWS
този.
2019 26 of 32.
JAWS for Windows, който струва, нали, на правителството самата пари, работи по един и същи начин. Самите слабо зрящи и незрящи хора работят по начин, който вместо да виждаме и да пишеме код и така нататък, чуваме, нали, както казах преди това, с глас какво ми казват на дисплея. Казвам демо.
FS Reader 3.025 of 30. Start with all apps list. Mic 3D view 7-zip folder. AIMP folder. Alarms and AI expanded. AIMP audio converter. AIMP audio converter.
Ще отваряме съответните приложения.
Desktop list.
Най-готиното е,
League of Legends 24 of 32.
най-готиното е, когато се налага да работим професионално и да пишеме код, отваряме нашето любимо Visual Studio.
Visual Studio Code. Alert info. There's start.
Виждаме, че тук абсолютно всичко се чете както трябва.
File submenu Alt plus F1. Edit submenu Alt plus E2 of 8. Selection submenu. File sub. New window. Open file. Open folder. Open workspace. Open recent submenu R6 of 18. D. C. D. WordPress local foundation sites templates agency. C. Users isma.e local sites isma. C. Users isma.e local sites isma.e website app public W. B.1 agency.html. File
тук съм
submenu
отворил
mainland bar.
един
Less doc type HTML greater.
един темплейт на Foundation Press firmware за фронтенд.
Less doc type HTML greater. Less doc type HTML. Less doc type HTML greater.
Абсолютно всичко скрин ридър се чете.
Less doc type HTML greater. Less HTML class equals Node.js lang equals and greater. Less meta charset equals UTF-8 slash greater. Less type, less link rel equal, less slash head greater. Less start top bar greater.
Общо взето даже не е мит, че хората с нарушено зрение не могат да пишат код и така нататък. Пишат си, като той те гледа и само да знаят какво пишат. Естествено, аз използвам всички нормални хора фреймворк. Дали Bootstrap или Foundation, всеки се избира сам. Ще ви демонстрирам.
Search window. Search box edit blank.
Как чете и в Search конзолата.
All tabs selected. Find the most tab apps. Tab apps. Tab select desktop menu options button.
Което се напише в самата десктоп среда, чете и въобще се справя според мен безпроблемно. Другото, което всеки може да го използва в своите разработки. Дали е то за web проект или за application mobile или desktop application, това е един идеален уред, инструмент за тестване на дали вашето приложение, апликация и web са accessible. Аз го ползвам от няколко години и да ви кажа, основно ползвам него, освен ако не трябва да тестваме за американски компании, които там основно използват JAWS for Windows, защото се покриват социалните институции за assistive технологии и така нататък. Ами, това е моята презентация. Ако някой има някакви въпроси, Леон или другите могат да ме попита, не е никакъв проблем.
Благодаря ти много за тази презентация и демонстрация. Няколко въпроса, които на мен първо ми идват. Как се справя с български?
Ами, с български се справям с така известния ни проект. С български се справям с така наречения синтезатор SpeechLab 2.0, който, за съжаление, не се поддържа. В смисъл, нашия познат Стоян няма интерес към него и не иска да го поддържа, защото нямало печалба и така нататък.
За съжаление, NVDA не поддържа български, така ли?
Поддържа. Поддържа eSpeak, който всички го знаем, който е open source, и поддържа Microsoft SAPI 5, който поддържа така наречения SpeechLab 2.0, който поддържа български език.
Супер.
Аз нарочно пуснах български, нарочно пуснах английски синтезатор, за да мога да видите как чете код, защото български малко... Код с български език не се пише.
Интересно. Какви са твоите наблюдения върху хората в България, които имат зрителни проблеми, тяхните предпочитания от към open source приложения, които да могат да решат този проблем? NVDA е от предпочитаните ли?
Ами NVDA според мен е от най-предпочитаните скринридер open source приложения, защото ти позволява да бъдеш flexible и да го използваш напълно пълноценно, както в работата, така и за ежедневна употреба.
Тъй като аз в началото съобщих, че ние с теб всъщност се познаваме от различни срещи на Linux за българи. Сега не мога да не те попитам как седи въпроса с Linux дистрибуции.
Ами с Linux дистрибуции аз лично предпочитам да използвам Debian базирани дистрибуции, Ubuntu и RPM Fedora, но за съжаление Orca скринридер, който е основният скринридер за GNOME, един единствен, няма интерес да се развива напред. Доколкото аз съм член в Orca, мейлинг листата на Orca съм член и там чета някакви неща. Нали, и в Phonomics форума, който е Linux-кия. Доколкото съм чел, Orca се разработва единствено от една жена, там един девелопър. Един девелопър няма как да смогне да фикси всички бъгове, които са.
Това винаги е сериозен проблем. Намирането и финансирането на разработчици на такива на всякакви open source проекти, но специално на такива случаи.
И нали, другото, което е, че просто в другите държави, хората, които ползват open source, нали, аз слава богу, си виждам, нали, и мога да използвам когато си поиска. Не ми е проблем. Ползвам Windows, защото тествам сайтове, работя с сайтове, нали, просто върши ми повече работа. Не, че нещо много го обичам, ама в крайна сметка човек използва това, което ми изкарва пари. Но ако Orca се направи като NVDA напълно функционална и работеща, въобще няма да се мисля да мине Linux.
Ти спомена, че голяма част от NVDA е написана на Python, както и че се задвижва отзад с SPEAK. Какъв е шансът да го видим за други операционни системи извън Microsoft?
Ами за момента шанса е минимален, защото последно, където четох, в NVDA списъците екранни, нали, в NVDA списъка, Бях казали, че за момента за Linux Operation OS не се предвижда. Да се импортне, да се инклюдне. Защото предполагам то в сайта, нали, като отворите nvaccess.com, това е нали, много Visual Access сайта на NVIDIA официалния. Там се пише, че официални спонсори са Microsoft и Google. Сега не искам да хейта никой. Всеки си гледа неговия бизнес, нали? И основно NVAccess фирмата се издържа с ръководства за Microsoft продукти, които са платени, нали, бъндали, Microsoft Excel, Microsoft Word и така нататък.
Аз от няколко години като странично хоби имам гласови асистенти за домашна автоматизация. Ти пробвал ли си такива, могат ли да улеснат живота на човек, който има проблеми с зрението?
Ами аз в момента използвам Google Home като официален гласов асистент. И да ти кажа, ми е доста полезен. Отделно си използвам Google Assistant. Чете новини, казва времето, напомня ти за срещи, сетва ти аларми. Аз лично съм доволен.
Какви са твоите виждания като човек от IT сектора, който е запознат с проблемите на хората с нарушено зрение? Какви са твоите виждания за бъдещето? Какво трябва да бъде променено в тези софтуери, за да станат по-добри и по-достъпни?
Ами, моето виждане е за... Аз не бих казал, че съм човек от IT сектора, просто си работя някакви работи, но моето виждане за в бъдеще на софтуерите като операционни системи, отделни апликации, отделни такива voice assistant като Google Home, Alexa, Siri и така нататък, трябва да бъде тяхното използване масово популяризирано сред всичките хора, които не само с зрително увреждане, а с всякакъв вид увреждания. Примерно дикшенерито, където диктуваш и компютърът ти пише, това било много полезно за хора, които са без ръце или с една ръка или някакви други двигателни проблеми. Примерно аудио description, на които караха Netflix, когато няма говор на филма, да има отзад аудио description, също е полезен. Да. Другото, което всичките сайтове в публичния сектор, НАП, КАТ и така нататък, те трябва да бъдат естествени от всякакъв вид хора с увреждания, за да бъдат достъпни.
Ти отваряш една доста интересна тема. Смяташ ли, че сайтовете на българските държавни институции в момента са достъпни? Ами
аз преди 2 или 3 години участвах в един проект, бях Quality Assurance за Accessibility и се сблъсках доста сериозно с тези сайтове и мога да кажа, че те не са достъпни. Независимо под Windows, под Linux, под Mac, не са.
Със сигурност това е нещо, което...
Сега, което там, като изключим тия елементарни сайтове, които сайт на Народното събрание, сайт на Народния театър, там освен хедери и параграфи, там няма по-друго да се чете, това се чете. Обаче да си платиш данъците, да си платиш глоба в КАТ, да си платиш вода, топлофикация и така нататък, с тези security на Google Recaptcha или там, където има да редиш картинки, не са достъпни.
Имаш ли представа как в другите страни успяват да решат примерно този проблем с кепча Какво би посъветвал web девелопър, който прави интернет страница и трябва да бъде достъпна за всички хора? Какво би използвал като алтернатива?
Я го посъветвал, аз основно използвам, те много хора го наричат, но използвам Hidden Field, така наречения honeypot, който го има и за WP Forum, и за Contact Form 7, и за другите. Да добави такова невидимо поле, което само ботовете го виждат и като го помня, значи, че е бот, това от security гледна точка и да не му се приема реквеста за регистрация. Другото, което бих ги посъветвал, да добавят 2FA, нали, две-факторна верификация, която ти идва код на мобилния телефон. Мобилният телефон ти прочита, че те са екрания, какъв е кодът, си го веждаш в полето. И така. Както са направили в Facebook и Google и големите IT компании. Там няма нужда въобще да гледаш картинки, да редиш светофари, тротуари, автобуси и пешеходни линии.
Да, разбира се, всъщност това са много добри идеи за решение.
Това е моята гледна точка, че когато верифицираш потребителя с мобилния си телефон или имейла, пиш си имейла, ето ти линк, кликни на линка, ако си ти си, ако не си ти, съжалявам. Според мен на Google рекепчета е морално устаряло. И хубаво слагаш рекепча, ама както сега преди моята лекция с колегата от Slack тествахме, аз се логнах с неговото име в тестовата среда. Кучетата просто не се бяха изчистили и какво правим? Ако се логна с твоето име в интернет банкирането, ще правя какво си искам.
Да, разбира се, това са проблеми, които в нашето съвреме все по-често се случват. Където има софтуер, има и бъгове, колкото и да се...
Това, което каже, че пише софтуер без бъгове, значи или лъжи, или не пише софтуер, или нищо не прави. Но това с достъпността, за съжаление, в България е голям проблем. Проблема е в магазини, в големи хранителни вериги, технически вериги и така нататък.
Може ли да резюмираш това, което ни показа и демонстрира накратко хора, които са с зрителни проблеми, не са имат компютърна грамотност, но не са експерти, откъде да започнат, как могат да е по-достъпно?
Смисъл?
Какви насоки би казал на хора, които имат зрителни проблеми и искат да могат да ползват пълноценно компютър в България? Какви open source софтуери, освен NVDA, бих препоръчал?
Бих препоръчал Mozilla Firefox за браузър и Chrome. И Chrome няма как да не е достъпен, защото целият свят го ползва. Бих препоръчал Notepad++ за текстов редактор. Ако пишат код, бих препоръчал Visual Studio Code. Говоря само говоря за Windows в момента. Visual Studio Code, добрият стар Winamp има още форк, който работи. Winamp за музика също става. За видеоплеер бих препоръчал GOM Player и Kind Player. Те имат интегрирано в тях Accessibility TTS, които четат субтитрите. Предполагаме, че си го пробвал. Ползвал под Windows, не? Бих препоръчал друго. LibreOffice, за съжаление, не е достъпен. Не е направен като хората. QBitTorrent бих препоръчал за торрент клиент. FileZilla за FTP клиент. Говоря неща, които ползвам аз.
Признавам си, хвана на тясно, аз от доста години не съм ползвал Windows и не съм... доста съм се дистанцирал.
Иначе конзолните приложения за писане, нали, те си работят. Даже мене някой път ми е по-лесно да пиша, отколкото да гледам с мишката и да кликам.
Тези програми, които изброи, по-голямата част от тях са специфични за Windows. Все пак за ентусиастите, които искат да ползват достъпни приложения под Linux.
За Linux бих препоръчал, който ползвам аз. Това е Fedora и Orca Screen Reader и да ползват чист GNOME.
С GNOME от десктоп средите е най-достъпен, така не? От тези, които ти си пробвал, разбира се.
Аз само не го ползвам от 3 насам.
Да.
KDA не е въобще достъпна среда. Да ползват чист GNOME и да ползват Qt3 графично базирани среди, като Mate и Canela, Cinnamon. Cinnamon, нали си лежи на GNOME, тя няма как. Ако нещо съм бъркал, поправя ме, нали...
Аз имам определени интереси в тази сфера. Беше много приятно, тъй като това е абсолютно познат проект за мен. Надявам се, че това, което казваше, е полезно и за много от хората, които ни гледат.
Аз казвам, което ползвам аз. Linux ползвам GNOME и Fedora, Windows ползвам Windows заради работата. Ако има някакви други въпроси, оставям на линия Facebook, социални мрежи и така нататък. Надявам се да съм бил полезен. Надявам се много хора да са разбрали как работят екраните, чици и така нататък.
Благодаря ти много. За момента нямаме други въпроси. Благодаря много за презентацията, за демонстрацията, както и за това, че сподели личния си опит. Още веднъж благодаря, че се включи в OpenFest и се надявам, че до година ще можем, освен да има виртуално събитие, да има и физическо събитие, да се съберем.
Благодаря много.
Добре, доскоро останете на линия, защото в 4 часа продължаваме с следващата презентация в този поток, която е на коренно различна тема. Тя ще бъде за, отново обаче, Open Source, за Open Source в космическите технологии. Сигурен съм, че ще бъде интересно. Кратка почивка, след това OpenFest продължава.
И сега към следващата ни лекция. Лекторът е Георги Калудов. Той е... Към следващата ни лекция. Имаме ехо, мисля.
От мен беше, извинявам се.
Да, няма проблем. Всъщност лекцията ще е на английски, така че може да преминем плавно. Our next lecturer is Georgi Kaludov. Georgi has 12 years experience as technical specialist and delivery manager into the biggest global tech companies. And in the last 4.5 years, he is leading IBM Systems cognitive hardware support teams. He's here to talk to us about the developments in the space technology space and to introduce to us some of the open source projects in that area. So, Georgi, take it away, please.
Thank you, Петко. По принцип, мога да направя лекцията и на български и на английски. Има ли как да разберем кои от хората, които са се записали и участват? Има някой от тях, който не разбира български?
Ами, можем да помолим в чатовете да се драсне, ако има хора, които... if anybody wants the lecture to be in English, please give some sort of sign.
Drop a message or a question in the chat, yeah, and I will quickly switch in English. Until then, if you like, we can continue in Bulgarian.
Okay, I believe мисля, че нямаме някакъв фидбек, така че...
Добре. Имаме съобщение от Contact Forum да започне на български, така че в чата. Добре, имам една молба. Не мога да видя опцията за споделяне на екрана.
Сега го правим. Ето, сега би трябвало да може да започне всичко. Сега? Да, добре.
Вижда ли се добре екрана?
Да, всичко е.
Добре, а сега добре.
Да, отново презентацията се вижда.
Добре, чудесно. Ами, здравейте всички. Днес ще ви занимая с една, за мен лично много любима тема, свързана с космическите технологии или с тех индустрията, като ще се опитам бързичко да ви разходя няколко основни елемента или неща, които знам, че всеки един от нас трябва да знае. Сигурен съм, че много от вас знаят. Но се надявам да ви споделя доста неща, които все още не знаете. Ще започна с кратко представяне на себе си, защо съм тук и защо ще говоря точно на тази тема. Благодаря, че ме представи. Казвам се Георги Калудов. По образование завършил съм Националната районна математическа гимназия в София. Профил математика и информатика, с много интерес също към физиката. В последствие завърших в Техническия университет на бакалавърска степен авиационна техника и технологии. Причината за това ми образование е, че от малък винаги съм обичал да гледам към звездите и към космоса. И ми е било мечта още от 4 годишен да стана космонавт. Още когато започнах да чета към 5-6 годишна възраст, започнах да се интересувам как може един човек от България да стане космонавт. И след това в училище си дефинирах своята стратегия как да стигна до космоса. Значи, достигнах тогава, беше в началото на 90-те години, до два начина. Единият беше да съм гениален учен, който да бъде изпратен в космоса и да прави съответно научни експерименти. поради природни съображения това не беше вариант за мен, тъй като не съм особено влиян, но в втория вариант, до който открих, беше да станеш военен пилот. При това най-добрия военен пилот в България, там най-добрия в НАТО, да отидеш в Щатите, там да станеш също най-добрия военен пилот и да кандидатстваш в програмите на НАСА, за да караш совалката. Затова започнах да се занимавам с авиация, защото си мечтаях да стана пилот на изтребител и да стана пилот на совалка. За съжаление, още в гимназията се случи нещо с организма ми, което не позволи да стана военен пилот на изтребител. В 9 клас вече станах висок, 1,87 м, и се оказа, че по принцип по-ниските хора, максимум 1,80 м, се представят по-добре на изпитания с изтребители, тъй като земното ускорение е доста сериозно и разстоянието между сърцето и мозъка на човека при по-ниските хора е по-малко, съответно налягането или ускорението, земното ускорение или няколкото жета, които трябва човек да изтърпи преди да падне, са доста повече при по-ниските хора. В крайна сметка това ми попари мечтите да стана пилот на изтребител, но реших за утешителна награда да се боря да стана пилот от гражданска авиация. Влязах в технически университет. По мое време имаше държавна поръчка. Първите 10 човека от випуска, които завършват авиационна техника и технологии. Класирането беше на база психотест, медицински тест, общ успех и английски език. Държавата им поемаше обучението за пилоти, което и тогава и сега е доста скъпо. Десетки хиляди евро, 50 хиляди евро, а пък тогава нямаше възможност да се вземе заем. Успях да се класирам в първите 10, но видиш ли, държавната поръчка беше прекратена точно за нашия випуск. В крайна сметка бях на кръстопът с какво да се занимавам и започнах в IT. Но няма нищо случайно. Започнах в Hewlett Packard Enterprise на няколко различни роли. Първо, второ, трето ниво support за Windows сървъри, както и за Citrix Enterprise системи. В последствие станах team leader на екип, менеджер и в IBM дойдох вече преди почти 5 години като менеджер на екип, който се занимава с поддръжка на така наречените power сървъри, доста мощни машини, върху които доста често върват AI, изкуствен интелект, хибридни клауди, среди environments на клиентите. И в IBM открих доста много интересни неща, които мога да правя, освен day job ми, който е да бъда менеджер на екип. Както казах, любовта ми към авиацията никога не ме напускала, въпреки че влагам 100-120% от себе си в всичко останало, което правя в момента. Тук виждате снимки от първи ми летателен час, който ми беше подарен от моята съпруга. На снимката отдясно обичам да играя в футбол, обичам да пътувам с съпругата си Неди. Обичам животните, различни видове екзотични животни. И също много обичам дъщеря си, която е на 1 година. Общо взето с тези няколко снимки се описва кои са нещата, които обичам да правя и които правя ежедневно, ежеседмично и така нататък. В работата си, както казах, имам опити като технически специалист и като менеджер на различни екипи в 2 от най-големите компании, които се занимават с IT, услуги и продукти. В момента отговарям за екип. Половината от екипа ми е в София, другата половина в държави в Централна и Източна Европа и в скандинавските държави. Страхотни хора. IBM не е случайно място и се радвам, че попаднах там. Като странични проекти ръководя някои от workstream-овете на няколко глобални проекта. Един се занимава с изграждане на умения на хора в нашата компания, в някои отдели. Другия е университетските отношения. Работим доста добре с няколко университета в София и извън София. Занимавам се с една програма, в която помагаме на Sales да откриват нови възможности за продаване на продукти и услуги. И в последната година участвам в 2 глобални инициативи на Academy of Technology, Едната се нарича Responsible Impact, а другата се нарича Space Tech. Идеята на тези инициативи е, че обединяват хора от IBM и хора извън IBM с определени умения и експертиза около обща цел с идеята да направят някакъв импакт или да променят дадена индустрия или даден елемент на ежедневието на хората. Разработка на нови технологии, прилагането на технологии в различни индустрии и така нататък. Доста интересно. Имам интересна награда също тази година да споделя от Global Vice президента Крис Конарски, свързане с общото шарената ми дейност, така да се каже, по различни проекти, допринасяйки на едновременно на бизнеса и на разпространението на технологии, които подобряват човешкия живот. Какво ме вдъхновява да се занимавам с доста неща? Аз вярвам, че хората, технологията и иновациите са основните причини, които помагат на нашите общества да се развиват, както и на света да прогресира. Технологиите са тези, които могат да намалят глада, технологиите са тези, които могат да ни спасят, надяваме се, от климатичните промени. Технологиите са тези, които също са ни помогнали да постигнем най-висшите постижения на човечеството, като премахването на проблеми и дори нашия живот, че дори съществуването на човечеството е просто една машинка. Може да звучи понякога депресиращо или отчаиващо, за някой пък твърде далечно. За мен лично това звучи мотивиращо или по-скоро стимулиращо любопитство. Какви интересни неща, нови елементи, нови видове планети, нови същества, може би и разум, се крият някъде в някои от другите трилиони точици само на тази снимка. Така че ние сме толкова малки, че може би единственият път, който е отреден като обща цел на човечеството, е да открием може повече за това огромно богатство от все, което е около нас. Така, сега бих искал да опитам да направим нещо заедно. Не знам дали има въпрос, ние да виждаме в чата въпросите, които ще се появят, тъй като ми се иска да е малко по-интерактивно. Дали въпросите ще се появят в публичния чат?
За момента няма още въпроси, иначе да, ти ще ги видиш, когато се появят и от всички канали ще ги добавяме.
Добре. Петко, ще мога ли тогава да ми помагаш, тъй като аз не ги виждам, когато си изподелям екрана?
Разбира се, да.
Целта е следната. Има няколко важни дати, свързани с космическата индустрия, които бих искал да проверя и всеки от нас да си напомни, тъй като съм сигурен, че всеки от нас знае за тях. Идеята е, когато видите дата, напишете, моля ви, в формата за въпроси или директно в чата с една дума какво според вас се е случило точно тогава. Опитайте се да не използвате Google. Първата дата е 4 октомври 1957. Имате около 5 секунди. Кажете първото нещо, което ви идва на ума и какво се случило тогава.
Понеже не виждам предположения, няма да видим моето предположение, да не би да е някоя от мисиите, може би тогава Съветския съюз да е качил първия спътник, нещо такова.
Добре, добро предположение. 4 октомври 1957, първият космически апарат, който човечеството изпълнява в космоса. Това е първият спътник, наречен Спутник. Спутник 1. Така че браво, много добро предположение. Общо заето това е за момента си тогава е било най-голямото постижение на човек. първи път изпращаме нещо извън пределите на атмосферата. Сигурен съм, че повечето от вас знаят, че атмосферата се простира на около 80 км над земната повърхност. Та за първи път успяваме да изпратиме спутник 1957, тогава СССР. Добре, втората дата 12 април 1961. Може ли някой да познае какво се случи тогава?
Чакаме предположения по каналите.
Да.
Имаме предположение от Благовест, първата мисия в космоса, което предполагам първата мисия с изпращане на хора в космоса.
Точно така. Юрий Гагарин, първият човек в космоса и първата мисия, в която изпращаме човек и той се връща жив и здрав.
Извинете, е коментара.
Добре. Ами да, така е, приемам отговор за верен. Трябва да помислиме за награди след това, за хората, които познаят. Така е първата мисия с човек в космоса, който успя да се върне. Много е вероятно да има от други мисии с хора, които не са се връщали, просто не са ги обявили. Знаете, че тогава е било студената война. Съединените американски щати и Съветски съюз впрягат абсолютно цялата си икономика, целия си ресурс, всички учени, индустрии и компании да работят заедно с правителството, за да се състезават кой ще изпрати пръв човек в космоса. И 1961 на 12 април СССР успяват първи да изпратят човек в космоса и да го върнат жив и здрав. Така че това е отново паметна дата, която е хубаво да се помни. И още една дата, последната дата, за която ще говорим е 1969, 20 юли. Имате 7 секунди, за да сме сигурни, че Google няма да помогне. Да познаете какво се случи тогава.
Добре, тези да минават 7 секунди. Имаме Калин Илиев, кацаме на Луната.
Точно така, браво на Калин. 1969, още взето от 1961, след като СССР печелят битката за изпращане на човек в космоса, след това Щатите и Русия започват следващата битка за това кой ще изпрати пръв човек на космоса. Защо казвам битка и защо казвам, че това има огромно значение? Защото това е първият път в историята, в който почти целия свят, всички учени, компании, правителства работят заедно с обща цел. Да, разделени на две, което значи половината правителства с половината индустрия и така нататък. Но този момент на състезание, в същото време с ангажираност, тогава Джон Кенеди излиза 1961, започва да говори пред цялото американско население и казва, че изпращането на човек до националната сигурност както и за запазването на американска нация да се впрегне и да работи върху това. Като не знам дали можете да си представите 1969 до какво ниво са стигнали технологиите тогава. Говорим за към технологии, уреди и така нататък. Тази битка между нациите всъщност допринася патент, основополагащи технологии, които в последствие променят света на човечеството. Общо взето всяка позната технология, всеки уред, който имаме вкъщи, като започне мобилни телефони, компютри, дори електричеството, което използваме, осветление, отоплителни системи, след това автомобили, самолети и така нататък. Абсолютно всеки един от тези уреди има поне частица иновация, която е била благодарение на тази битка за достигане до американците, успяват, изпращат мисията по 11 и първият човек, който стъпва на Луната е Нил Армстронг и тогава всички знаем крилатата и поетична фраза. Една малка стъпка за човека, огромен скок за човека. Които бележат химическата индустрия. Една от причините съм горд, че победят СССР, тъй като за първи път са били мейнфрейм машини, тогава са били цели стаи компютърни системи, с помощта на които са ги програмирали, за да изчисляват реактори, да изчисляват колко гориво ще е необходимо, да изчисляват по какъв начин точно трябва да заходи Apollo 11. Също и лунния, точно с каква скорост, какво ускорение, под какъв ъгъл и така нататък, трябва да се предвижи, за да може да съответно да излети и след това от нашата компания са участвали тогава и това е нещо, което много се гордеем. От тогава се случват интересни неща с индустрията. Има основните общо взето институции и компании, които се занимават с това, са НАСА. Дълги години те продължават да изпращат мисии до космоса и до Марс. Общо взето владеят космическото пространство. Също Русия инвестира, но значително по-малко. Последните години Китай, Индия, Пакистан, също и Европейската космическа агенция, ESA. Общо взето има доста сериозни играчи на този пазар и буквално космическата индустрия започва да става все по-комерциална. Всички сме чували и сме гледали клипчетата на SpaceX, Елон Мъск, който е голям визионер и е човек, който също направи много за Space индустрията. Неговата цел е да я комерциализира, докато НАСА и Европейската Space Agency се стремат космоса да бъде използван повече за научни цели, но в крайна сметка живеем в свят на пазарна икономика и начина да се инвестират такива огромни суми, каквито са необходими за да изпратите нещо в космоса, е максимално много компании и индустрии да имат полза, или съответно държави да имат полза от това да бъде изпратено нещо тяхно в космоса или да изпращат хора или изследвания да се случват извън Земята. Затова и НАСА, и ESA, и SpaceX се стремят да направят изпращането на сателити, например, или хора в космоса възможно най-достъпно от към технологична гледна точка, от към ценова гледна точка. Тъй като грубо мога да ви кажа, че изпращането на един спътник в космоса може да ви струва между 200 хиляди до половин милион долара, понякога 2-3 милиона, зависи колко е голям и тежък спътника. Като тези цени, които ви казвам, са за малки спътници, CubeSats, така наречените, които са 10 на 10 см. Вече по-големите, с увеличаване на килограмите, които искате да изпратите в космоса, цените растат значително. Затова голям пробив напоследък, и това е хубаво всички да го знаем, направи SpaceX, защото преди тях само НАСА имаха общо совалки, като разликата между совалка и ракета е, ракетата е нещо, което се използва еднократно за изпращане на нещо в космоса. Ракетата се разпада, когато изпрати спътника в космоса. Всъщност спътника е само горната част върха на ракетата. Всичко останало надолу е двигател и гориво. Изключително голямо количество гориво е необходимо, за да се преодолеят тези 80 км до открития космос. В крайна сметка ракетата е нещо, което се използва веднъж и след това се разпада. Докато совалката е нещо, което се изстрелва с помощта на допълнителни резервуари и двигатели в космоса и след това космонавтите се връщат заедно с совалката. И съответно совалката може да се използва отново. И това намалява изключително много цената. И вместо няколко милиарда, за да изпратите нещо огромно в космоса, ви се намалява, нали, на половина, на една четвърт и така нататък, защото само правите поддръжка след това на совалката и пак я изпращате нагоре. Звучи лесно, нали, това правене на поддръжка. Не е лесно, но в крайна сметка излиза доста по-евтино. Та SpaceX направиха така, че направиха ракета, която е за многократна употреба. Дори направиха няколко. Ако сте чували за Falcon 9, която е доста голяма, доста мощна, една от най-мощните ракети и двигатели, които някога са създавани от човек. Между другото е ракета, която изстрелва нещо в космоса, например Falcon 9. Мощността на двигателя се равнява на мощността, не се разпадат или не се унищожават, ами след това се приземяват напълно автономно, без човешка намеса. И може би сте виждали как, нали, тръгват да падат, включват двигатели и се приземяват вертикално и то на платформа в океана, без човек да ги управлява. Нещо, което, нали, имаше доста неуспешни опити, но в крайна сметка успяха да го постигнат. И от тогава, нали, интереса още повече се повиши. Говори се за изпращане на хора в космоса, от една страна с научни цели, от друга страна с комерциални цели, от трета страна за space туризъм. Хора да бъдат изпращани в орбита. Вече има няколко случая на милиардери, които са си платили да отидат до международна, която се движи постоянно в орбита около Земята, само за да стигнат там до космоса, и това е нещо, което може да се прави, вече е правено. Започна също нещо много интересно, мисията Артемида на НАСА, която цели следващите 3 години да изпратят хора на Луната отново, да изградят станция там и до 2035, ако не се лъжа, да стартират първата мисия с човек към Марс. В същото време SpaceX имат също желанието да го направят дори още по-рано, преди 2030, така че има отново някакъв елемент на съревнование, което обикновено е добре за мотивацията, ангажираността и за стремежа да се постигнат тези нови високи цели за човечеството. В крайна сметка, за изпращането само на един спътник е нужно да си осигурите ракета, да си осигурите горивото за тази ракета, технологията, която е необходима, да си осигурите сателит с всичките технологии, които ще са ви необходими в него. В крайна сметка трябва да вземете всички необходими разрешения от агенциите, които отговарят за въздуха на държавата, където ще си изстрелва, също и от спейс агенциите. Това прави изстрелването на сателит доста скъпо начинание. Също около това имате ресърч или иновация на нови технологии, тяхната изработка или произвеждане, след това интегриране в различни индустрии, доставяне на частите, сглобяване, подготовка на самите полети и изстрелване, след това привръщане, има също доста разходи. Това е индустрия, която до 2040 някои различни източници казват, че ще достигне повече от 1 трилион. Както виждате, различните източници казват различни цифри, но всичките са съгласни, че ще е над 1 трилион индустрия, което значи, че може да очакваме доста инвестиции, интересни неща. Защо сме тук и какво всъщност искам да ви разкажа, свързано с тази огромна нова индустрия, която се разраства експоненциално в момента? Има доста IT технологии, които биха били изключително приложими и днес се прилагат в спейс индустрията. В изпращането на товар в космоса, в изпращането и производството, доставките и така нататък, могат да се приложат технологии, където все още не са приложени, за да се намали цената на дадената услуга или продукт или изстрелване на нещо. Също и да се намерят нови приложения на сателити или хора, изпратени в космоса за различните видове промишлености и индустрии. Например, в момента почти всички по-големи телекомпании, телекоми имат изпратени сателити. Дори една българска компания, Bulsat.com, ако си спомняте, преди около 2-3 години в новините, казах, че са си изпратили техен сателит, собствен сателит, който между другото беше изпратен с SpaceX, ако не се лъжа. Компанията. Каква е причината? Ами защото по този начин могат да си позволят да излъчват техния сигнал за определени канали глобално, без да се съобразяват с кабели или с локални земни излъчватели и да плащат различни такси на различни държави. Просто имат сателит, плащат си каквото трябва, за да им се поддържа сателита горе и излъчват от там. Също много радиа използват подобен модел, но с по-малки сателити, CubeSats се наричат, споменах ги малко по-рано, малки сателити 10 на 10 см, има различни размери, разбира се, но един сателит 10 на 10 см е напълно достатъчен да излъчва радиосигнал и то на голяма площ над Земята. Така че ако някой си вземе поне 3 до 7 сателита, може да покрие почти цялото земно кълбо с радиосигнал, което допреди не е било възможно. Други неща, за които се използват сателитите, следят се климатичните условия, следят се също ефектите от глобалното затопляне. Разбира се, военните ги използват от много години, от десетки години за следене с високо high definition камери, инфрачервени камери, общо взето от космоса могат да видят дори кръфица. Поставяне на Земята, стига да имат достатъчно ресурси да си го позволят. В същото време, да, искам да се върна всъщност на IT технологиите и как те могат да подобрят всъщност и да се открият нови сфери, където да се приложат. Та има няколко основни IT технологии, с които съм сигурен, че всички сте запознати, тъй като съм убеден, че много от вас, ако работят в IT индустрията, са се сблъсквали с тях. Блокчейн, нещо, което е много любимо, сигурен съм, на всички девелопери. Тази система за свързаност всъщност има изключително много приложения. И в една индустрия, в която имате много доставчици на различни материали, имате много регулатори, било то държавни, военни и така нататък, имате и страшно много документация, фактури, разрешителни и така нататък. И в същото време вие трябва всеки един момент да може да доставите достъп до тази информация на едни евентуални потенциални аудитори, които трябва да проверят дали всичко е наред. Блокчейн е технологията, която наистина в момента се прилага в няколко сектора, които са директно свързани с спейс индустрията, за да упростят и да оптимизират максимално всичкият товар, който се изпраща в космоса. Говориме не само за всички консумативи, нови части и така нататък, които се изпращат до Международната космическа станция, но също и за да се следи всеки нов сателит, който е изпратен в космоса, защото в момента има хиляди сателити, които се движат. Там някои от тях са доста остарели и в момента се наблюдава нов проблем, че има твърде голяма наситеност на сателити в космоса и много често има риск те да се сблъскат, като по този начин могат да паднат, нали, на Земята, могат да направят вреди, ако не изгорят напълно в космоса, също могат да унищожат някой доста скъп и важен сателит. Така че блокчейна е нещо, което може да помогне за оптимизиране на цените, за по-лесно свързване между различните елементи на индустрията. Digital Twin, това е нещо между виртуална реалност, augmented reality и всъщност копиране на действия или на команди, които някой задава на Земята и всъщност се случват някъде на някой сателит, лендър, ровър или някакъв друг обект в космоса. Например, чрез Digital Twin се управлява Предполагам, че знаете, че нас успяха да изпратят съдеход преди няколко години, той дори вече поостаря, вече не изпраща сигнали. Той направи доста за проучването на Марс. Той също беше управляван чрез Digital Twin, което всъщност е отново програмиране. Както блокчейна е доста програмиране, така и Digital Twin, за да създадете максимално оптимизиран код, за да може да е максимално лек, за да може всеки клик в системата тук или всяка команда да може да достигне максимално бързо до обект, който примерно е на Марс или на някоя друга планета и по този начин да се управлява. Активно, пък той връща сигнал, връща данни, които се анализират тук и отново се пращат обратно. Така че Digital Twin също е нещо доста интересно. Другото, което може да се прави чрез Digital Twin, код, който върви симултейниесли едновременно на два ровъра, например, може да са на различни планети, задавате команди и изпраща се едновременно от тях и така. Edge Computing, това е следващото еволюционно ниво на Cloud Computing, като Edge всъщност са всички периферни устройства, които се движат по краища, така да се каже, на клауда. Това са всякакви датчици за температури, светлина, които могат да анализират и да събират допълнително данни, свързани с големи суперкомпютри в клауда, за да може тези данни да се анализират максимално бързо с AI, изкуствен интелект. Като след малко ще ви покажа няколко приложения за това. Общо взето Edge Computing е свързано с между дейта центровете, самите обекти, които са в космоса и всичките датчици, които са свързани с тях. И накрая, не на последно място, квантов компютър. Ако не сте чували все още за квантовите компютри и не знаете какво представляват, моят съвет е потърсете в Google и в YouTube. Има вече страхотни видеота, които описват по много интересен, увлекателен и лесен начин какво също представлява квантовия компютър, с какво той е различен от сегашните компютри, които ние използваме и всъщност какъв невероятен потенциал има тази технология. Значи има не повече от 10 години, според мен, в които квантовите компютри вече ще бъдат използвани от доста индустрии. Те вече се използват за откриване на нови химически елементи, също така за анализиране на климатични условия, за предотвратяване на disasters, така че квантовите компютри са нещо, което наистина може да помогне, тъй като експоненциално могат да превишават способността дори на най-теоретично създаден компютър. Работи с единици. Квантовия компютър има нещо допълнително, освен с нули единици. Той може да работи с трето състояние, което е между 0 и 1, но няма да задълбочавам, тъй като това може да е отделна лекция. Междувременно има ли въпроси в чатрума, тъй като не виждам и ще ми е полезно, ако се появи, само да ме прекъснете, за да не се превръща в монолог.
За момента няма въпроси, не.
Добре. За блокчейн малко по-подробно. Това, което ви разказах, за да си изпрати един спътник, трябва да се премине през много стъпки. Освен производство, доставки, сглобяване, сертифициране и така нататък на спътника, след това трябва да се изпрати от някого в космоса. Много често компаниите, които произвеждат спътници, не са тези, които ги изпращат в космоса. Компаниите, които изпращат в космоса, са тези, които притежават ракетите, совалките и така нататък, докато други компании могат да произвеждат спътник. В крайна сметка, те отново трябва да имат някакви договорни отношения, трябва да се минават различни регулации, проверки, трябва да се минава през Mission Control Center, който много често е контролно звено. След това всеки сателит, който е в космоса, трябва да има постоянно управление. Всичко това е свързано с много документация, много комуникация, колаборация и затова блокчейн е технологията, която в момента няколко компании се опитват да приложат, включително и IBM, за да упростят този процес, да го направят по-достъпен. Защото ако вие, например, утре искате да си изпратите спътник, ще трябва да минете през всяка една от тези стъпки, да намерите съответната институция или компания, която да ви предостави услугата и най-вероятно ще се откажете още по средата на пътя, да не говорим, че струва и много пари. Та, ако има приложени вече интегрирани блокчейн системи, всичко това може да си съществува като една обща среда и стъпка по стъпка може да влезете в програмата и да видите къде какво е необходимо да нацъкате, да направите. И най-хубавото е, че пък контролиращите агенции, агенциите по сигурността, тъй като всяка държава си контролира въздушното пространство, въздушните, тези, които отговарят за въздуха, за авиацията и така нататък, както и тези, които отговарят за космоса, за съответната държава или континент, те също лесно може да им се даде достъп. Така че блокчейн е едно от евентуалните приложения, върху което вече се работи. Друго много интересно, споменах ви, че има изключително много сателити, които в момента са в космоса, голяма част от тях летя свободно и това създава постоянен риск от сблъсъци и замърсяване в крайна сметка на космоса. Така че в момента е много важно да се направи, да се идентифицира система постоянно движението на да дава сигнали, когато има опасност. Институцията или компанията, която контролира този спътник, да може да вземе необходимото решение или още по-добре, тъй като всеки спътник има своя система за управление и има някакъв процесор и способност да прави елементарни движения да се самоуправлява. Всъщност, може чрез блокчейн плюс AI да се приложи така, че на всеки от спътниците да има инсталиран определен софтуер, който при евентуално приближаване на два спътника просто сами автономно да се отклоняват от курса, така че да се избегнат едни други. Подобни системи съществуват и в авиацията и те предварят на самолети и в космоса, разбира се, говорим за други мащаби. Е активно, постоянно позицията си, в същото време комуникира с суперкомпютър, анализира мап, в който се вижда кой на къде лети, види, че може да се случи сблъсък, много бързо праща сигнал към двата сателити, те се разминават и така. Мога да ви покажа Разбира се, мащаба, който гледаме, е умален и за това ни изглежда толкова нагъсто. Когато си го представите, че това е с размерите на Земята, нали? Всъщност тези двата сателита, например, не са толкова близко. Освен това, всеки сателит си има своя орбита, различно разстояние от Земята, но в крайна сметка все повече и повече различни обекти има в космоса. И, както ви казах, единият фокус е така нататък. Space Situational Awareness. Тук идеята е следната. Има все повече комерциални компании, които поглеждат към космоса. През следващите няколко години дори няколко компании се целят да изпратят над 30 000 сателита в космоса. И това ще се даде още по-голям проблем, нали, за това замърсяване, за което си говорихме. Което значи, че трябва да се зададе първо някаква регулаторна рамка, която да бъде приета от всички, в началото може би американски компании и след това всички компании по се развива и да бъде отрегулирана по някакъв начин. Например, авиацията за самолетите. Авиацията е доста регулирана индустрия, защото има голям риск за животите на пътниците, както за самолетите, огромни загуби, ако нещо такова се случи, нали, сблъсък на два самолета или катастрофа. Затова самолетите летат на определени, така наречени ешелони, на определени височини. Тези ешелони са прияти от абсолютно всички държави по света и същи наименования, едни и същи разстояния и така нататък. И по този начин, когато един пътнически самолет по време на полета си преминава през 20 държави, във всеки един момент се знае той точно на кой ешелон лети, т.е. на каква височина. И това позволява на всяка държава, над която преминава, да може да координира така авиационното движение над нея, че да не се получи сблъсък. За това става въпрос, това се опитваме да разработим като код също така и за сателитите. Определени височини, ешелонизация, също, нали, код, който да бъде вграден на всеки един сателит, който се изпраща в космоса, за да може сам да си определя ешелоните и като подсигурим тази комуникация между тях, наистина е доста по-регулярно цялото движение в космоса. Тук може да видите линкове. Надявам се, че ще мога да изпратя презентация след това на всички, които гледат тази сесия, тъй като ще изпратя някои доста важни линка. Този единия е отворен проект в GitHub, отново е open source, в който всеки един от вас, който има умения по програмиране, може да се присъедини към екип от експерти от целия свят, които работят за разрешаването на този проблем, като знаете как работи GitHub. Обявяват се няколко проблема и хората дават предложения, пишат код. Може даже да не сте толкова добри в писането на код, но ако имате добро логическо мислене, може да дадете доста добра идея, която да заобиколи проблема. В крайна сметка става просто за работа в екип, да направим нещо хубаво за Земята и за космоса. Друг такъв интересен проект е CubeSat, Cognitive Autonomous Framework. Всъщност тук се опитваме да разработим фреймворк или рамка за самоуправление на CubeSat, на малки кубични сателити. Като идеята е тук да научим сателитите да се движат заедно в клъстър или по-скоро като Swarm, като ято. Представете си, примерно, че имате 10 CubeSat клъстъра и те си комуникират постоянно помежду си. Освен, че координират движението и орбитите си, за да могат, например, да осигурят покритие на цялата Земя или на целия континент по всяко време, тъй като те се движат постоянно около Земята. Също така могат да си задават едни на други цели. Ако целта им е да наблюдават климатичните условия и видят ураган, че, например, се задава към Щатите или към Европа, могат да координират помежду си от тези 10 сателита и да кажат, айде, нали, тези 3 сателита тръгват след този ураган и го следят постоянно, нали, за да видят как се движи, за да могат да предупреждават хората на Земята да се евакуират. Другите 3 сателита през това време може да харесат някакъв друг обект или да имат друга мисия. И когато се свърши мисията, се връщат отново, групират се и пак влизат в максимално оптимална орбита, в която осигуряват покритие, където се налага. Така че това също е доста интересен проект, където се иска доста мислене и програмиране и е нещо, което горещо препоръчвам. И накрая, но не на последно място, както казах, квантовите компютри, оптимизация, прилагане на изкуствен интелект и на машин learning. Всеки един от елементите на изстрелване на ракета, човек или сателит до космоса или до Луната или до Марс се налага оптимизация, така да се каже. В смисъл, цената на една мисия до Луната, както споменах, започва от $1 милион нагоре и това е за изпращане на един много малък CubeSat. Ако искате просто да изпратите нещо в космоса, минимум $200,000. Различни компании работят за това да направят пътуването или изпращането на неща в космоса доста по-евтино. Имаме българска компания, която искам да споделя тук, и това е EnduroSat, която се занимава с изработката и изпращането на CubeSats на сателити. Имат различни размери, предлагат различни услуги, различни хардуери и софтуери на техните сателити. И между другото, те са една българска компания, стартъп компания, която вече е scale-up, тъй като за последните 5 години доста са се развили. Те, например, са си наели SpaceX. Те си могат да си позволят да наемат SpaceX за тяхна мисия, да им изпратят един или повече CubeSats до космоса. Така че ако не сте чули за EnduroSat, гугълнете и вижте какви яки неща имат в сайта. Какво правят те също? Те буквално изпращат все по-умалени мини-сървъри в CubeSat и на тези мини-сървъри могат да направят така, че повече от един клиент да използва различни апликации на тези сателити. И това, както се сещате, ако една компания, например един телеком, иска да изпрати сателит да излъчва нещо от космоса, тя трябва да извади едни 200, 300, 500 хиляди долара, за да си изпрати сателит. Обаче, ако плати на EnduroSat, например, те на един CubeSat могат да качат някакви апликации. И, например, този клиент може да използва тази апликация, излъчване на някаква програма. Но в същото време те ще имат още ресурси и могат да продадат на още някой клиент да използва някоя друга апликация на същия сателит. И по този начин смъкват цената за клиента на половина, ако станат два клиента на този сателит. И представете си колко повече правят по-малък хардуера, нали, и по-лек, толкова повече клиенти могат да си позволят да изпратят с един сателит горе в космоса. И това прави доста по-достъпно това да използвате някакви данни от космоса. Например, един клиент ще си прати камера, друг клиент ще иска само излъчвател, третия клиент ще иска система за позициониране и по този начин 3 клиента си разделят цената за изстрелване на спътник. Това е само един пример и само една българска компания. Преди да се разделим, ще ви покажа няколко сайта, за които ще изпратя линкове заедно с презентацията. Освен този готин сайт, където наистина в реално време може да виждате какви космически обекти има, летящи в космоса. На тази публична страница може да прочетете за open source проектите и начините, по които вие дори днес, дори сега през ноември, можете да участвате в различни инициативи и проекти, в които вашите знания или вашите усилия могат да бъдат изпратени в космоса. Могат да бъдат изпратени на истински сателит, вашия код може да стигне там, или вашата идея може да бъде приложена за нещо свързано с спейс индустрията. Едното от нещата са тези два GitHub проекта. Единият е CubeSat или Cognitive Autonomous Framework и другия е Space Situational Awareness или разработката на тази рамка или фреймворк за движението на сателитите в космоса, за да може да бъде координирано и регулирано. Има едно събитие NASA Space App Challenge, което горещо ви препоръчвам. Случва се всяка година, когато гугълнете NASA Space App Challenge. Там може да се запишете, да участвате сам или да съберете група да участвате като екип и работите, за да разрешите даден проблем. даден проблем, който е зададен от нас. Не е нужно дори да имате технически знания, тъй като в един екип винаги имате нужда от експерти, в различни сфери имате нужда от хора пък, примерно, които могат да презентират добре идеята, имате нужда от хора, които просто мислят логично и обичат да свързват точките. Така че нека не ви спира това, ако нямате някакви задълбочени технически познания в някаква сфера. Това е за нас с SpaceUp. Това е друг линк, който ще ви изпратя. Тук е по-скоро философски въпроса. Имаме един AI, който се нарича Debater. Създадохме изкуствен интелект, който е оптимизиран да прави дебати. И тук му поставихме тема да дебатира дали според изкуствения интелект съревнованието между Щатите и Китай за космическите програми е нещо положително или негативно за човечеството. И тук също вие може дори да добавяте мнения, които изкуственият интелект, IBM Watson, може да анализира и в крайна сметка, на края на сайта, може да видите резултатите, всъщност до какви доводи достига изкуствения интелект. Нещо също интересно. В YouTube може да намерите интересни видео.
Да. С времето, но в смисъл има още минутка да довършим.
Добре. Има ли въпроси междувременно?
Няма. Да, за сега.
Добре. Да, това, което иска да кажа също, ако ви е интересно, в YouTube също има интересни клипове, като един е този IoT in Space. И тук може да видите как Наим Алтаф дискутира с VP-та от Cloud и от Strategic Customer Success, как също си какви технологии се прилагат в момента в сферата на IoT в космоса. Наим Алтаф го споменавам не случайно, тъй като той е Distinguished инженер, една от най-високите технически позиции в IBM и в същото време CTO или Chief Technical Officer, който отговаря за Space технологиите. Неговата задача в началото на годината е да развие максимално Space индустрията и я направи максимално достъпна за повече хора и за повече технологии. Доста интересни проекти движи той. Аз се радвам, че съм част от един от него. Още не мога да споделя публично, тъй като все още е конфиденциално, но се надявам скоро да имаме хубави новини. И последното е Call for Code. Това също е глобална инициатива, където се търсят хора, студенти, но не само, които могат да пишат код, но и такива, които не могат, за да се занимават с разрешаването и създаването на идеи за три основни проблема. Запазването на чистата питейна вода в световен мащаб, също създаването на нови начини за съхраняване и произвеждане на енергия и за възстановяване от disasters или от избягам и думата на български за дизастър. Петко, може да помогнеш.
Бедствие?
Бедствие, да, благодаря ти. Хубава българска дума. Добре, сега ще се опитам да спра да споделям екрана.
Благодаря ти, Георги, много за изчерпателната лекция. Това беше доста добър обзор на развитието на космическите технологии. Понеже нямаме допълнително време, няма и зададени въпроси в момента, ще поканя и теб и всички зрители да влезнете в интерпрет залата за дискусии. Там може да продължим тези интересни теми. И благодаря отново и с това приключваме за стримът за днес.
И аз много благодаря за поканата и достъпен съм навсякъде в LinkedIn, Facebook, ако някой има интерес по Space технологиите, ще се радвам да споделя информации, линкове и така нататък. Така че, Петко, много благодаря също за гостоприемството.
Страхотно. Благодаря.
Приятен следовете и ще се видим в дискусионната зала.